These eerie objects are called quasars. They're some of the brightest and most powerful objects in the universe. They lurk in the depths of space, consuming entire galaxies with their insatiable hunger. But what are quasars? Where did they come from? And most importantly, are they dangerous to us? Picture a supermassive black hole, a cosmic monster so massive that it can swallow entire stars and bend the fabric of time. Usually, there's such a black hole in the center of every galaxy. That includes our own Milky Way galaxy. Ours is named Sagittarius A star. Sounds like the name of a hipster coffee shop, but in reality, it's a terrifying celestial body, which is 4 million times heavier than our Sun. You could even see it online. For the first time, we took a photo of this black hole in May 2022. But don't worry. Even though it's supermassive, it's not going to swallow us up anytime soon. This black hole is relatively small, and is too tiny to eat an entire galaxy. So it's more like a cosmic vacuum cleaner that sucks up stars or gas that gets too close. But there are black holes in the centers of galaxies that are way heavier and more dangerous than ours. They can weigh millions or even billions of times more than our own Sun. Now, imagine one of these monsters. Usually they're surrounded by a swirling, glowing disk of gas and dust, like water swirling down a drain. It's called an accretion disk, and it's where the magic of quasars happens. As material from the accretion disk falls toward the center, it heats up to millions of degrees, releasing vast amounts of energy in the form of radiation. And this radiation is what we observe as a quasar. So basically, the more material a black hole can consume from its surroundings, the brighter its quasar will be. This is what makes them so bright and powerful, shining like beacons in the night sky. And just imagine, some black holes can actually make entire galaxies their meal. Now, combine their ravenous appetite with some intense radiation, and you'll get a truly awe-inspiring display of cosmic power. No wonder we can see them, even though they're some of the most distant objects in the universe. Quasars were discovered in the late 1950s by accident. Astronomers were just chilling and looking at the sky when suddenly they stumbled upon something strange. Radio signals that had no visible source. By 1960, hundreds of these strange objects had been found. Astronomers named them quasars, short for quasi-stellar radio source. These objects were small and far away, but their energy output was immense and difficult to explain. Some thought that these were new types of stars. Others even proposed wild things, like quasars being made of antimatter or being the end of a wormhole. But all these theories were discarded. A scientist named Martin Schmidt was the first one to get to the truth. However, many astronomers didn't believe him. Schmidt had to do a lot of extra work and gather lots of evidence to prove his theory. And finally, he prevailed. And that's how we discovered quasars. Don't you love the scientific method? And since then, astronomers have been captivated by these objects. Why? Because they have some pretty eerie qualities. You could call them quasi-quasars. For example, they kind of defy the laws of physics. They emit jets of particles that travel at speeds close to the speed of light. These particles move so fast that they can even distort the very fabric of space and time. But sometimes, they also help us confirm the laws of physics. Now imagine driving a car. As you drive, objects in the rear window start to appear smaller and smaller until they disappear from view entirely. That's exactly what happens with quasars, except they're moving away from us at incredibly fast speeds, up to 90% the speed of light. Wonder why they're trying so hard to sprint away from us. But in any case, this helps us confirm that the universe does expand for real. Another eerie thing about quasars is that they're incredibly old. Some even date back to the time when galaxies were forming, or to the birth of our universe. Additionally, quasars are some of the most distant objects that we can observe in the universe. Some of them are located billions of light years away from us. This means that when we observe a quasar, we're actually seeing light that was emitted billions of years ago, when the Earth was much younger and different than it is today. And that's why they work like cosmic time capsules. Studying them gives us a glimpse into the distant past. You see, galaxies are like giant cities, with stars and planets serving as the inhabitants. But just like cities evolve over time, galaxies also undergo changes as they age. And that's where quasars come in. They're like the urban planners of the universe. They shape the galaxies through their powerful gravitational influence. By eating galaxies and releasing intense radiation, they can trigger star formation and shape the structure of the galaxy itself. It's like the cosmic equivalent of a master chef, or a leaf blower, you pick. For example, let's take galaxy mergers. Here are two massive entities coming together, swirling and spinning around each other. As they get closer and closer, their gravitational pull becomes stronger, and they start to merge into a new, bigger galaxy. It's a beautiful and dramatic process, one that can take millions of years to complete. But all this doesn't go without consequences. The gas and dust within the galaxies collide, creating massive shock waves that trigger the birth of new stars and even supermassive black holes. And this is where the quasars come into play. Some quasars may be born during these galactic get-togethers, and thanks to this, they help us study the effects of this process and the evolution of galaxies over time. But it's not all serious science and no fun. For example, how about gravitational lensing? Now, that's something straight out of a sci-fi movie. It happens when the gravity of a massive object, like a quasar, bends the path of light from a more distant object, like a galaxy, behind it. It's like having a really big magnifying glass in space. When you combine a quasar with gravitational lensing, you get some seriously awesome cosmic eye candy. The result is kind of like a funhouse mirror, where objects appear warped and twisted in strange and mesmerizing ways. Gravitational lensing isn't just for show. It's also a powerful tool for astronomers to study the distribution of dark matter and the structure of the universe. And that's not all. Some scientists have proposed that quasars could help us build the map of the universe. They can work like giant neon road signs. Turn left at the quasar and you'll reach your destination. They're like lighthouses that help us navigate through space. By analyzing the light from different quasars, astronomers can determine the distances between them and create a 3D map of the universe. And the best part? Quasars are located throughout the entire universe. That's why this cosmic map can give us a comprehensive view of the universe on a scale that was previously unimaginable. Who knew that a giant galaxy eater could be so useful? There's still a lot we don't know about these mysterious objects. In 2007, a team of astronomers made an astonishing discovery: the first true binary quasar. Basically, this means two huge quasars spiraling around each other. What's more, they were hiding in plain sight. For years, scientists had known about this radio source, but had never realized that it actually comes from one lovely couple. The astronomers also estimated that this pair may have a mass of about 100 billion suns. They're super distant, though, at an astounding 12 billion light-years away from our blue planet. Overall, quasars are a fascinating and complex phenomenon that continues to baffle and intrigue scientists. They may be cosmic galaxy eaters, but they're also playing a critical role in the formation and evolution of the universe. And who knows, maybe one day they'll become one of the keys to unlocking the mysteries of our universe. Oh, you crazy quasars.
It's dark and incredibly cold. There's no oxygen. There's no water. There's no life. But the James Webb Space Telescope doesn't seem bothered by all this. Its main goal is to find the very first galaxies that formed billions of years ago in the early universe and observe the stars making up distant planetary systems. Its mission is to… But wait, what is that? The James Webb Space Telescope has discovered something absolutely amazing: a star-planet hybrid with very strange clouds. This bizarre world called VHS 1256b is actually a brown dwarf. Those are bigger than planets, but too small to classify as stars. They emit some light of their own and are quite hot, but their mass is simply not enough to fuse hydrogen into helium, like full-fledged stars do. Space bodies of this kind aren't actually brown. They occur in a wide variety of colors, but those are mostly invisible to the human eye. What we can see is the light they emit, and to us it appears to be dark orange or magenta, The brown dwarf we're talking about is almost 20 times the size of Jupiter. It orbits 2 red dwarf stars. And to complete one orbit, the brown dwarf needs 17,000 years. In fact, astronomers found out about this unusual exoplanet in 2016. But at that time, they didn't classify it as a brown dwarf, and thus couldn't explain its puzzling reddish glow. Now, thanks to the James Webb Telescope, they know the space object's origin. Anyway, back to those clouds. As you know, clouds on Earth are made of water vapor, but those on the brown dwarf are different. They seem to be made of sand. It looks like good old sand from Earth, but it's actually not. The clouds are made of tiny particles of silicate. Scientists have been putting forward theories about the existence of such sand clouds on exoplanets for quite some time. But the discovery the James Webb Space Telescope made is the first real proof. The silicate particles on the sandy dwarf are most likely quartz or some other mineral. In size, they're less than a micron, and 1 micron is 1/25th of a thousandth of an inch. In other words, they look like particles in smog. The exoplanet seems to have an atmosphere which contains some water, methane, and other substances and minerals. Interestingly, this atmosphere isn't still. It's constantly undergoing extreme changes. Another cool thing about it, scientists have detected carbon dioxide. And this is only the second confirmed discovery of this gas on a planet outside the solar system. By the way, the James Webb Space Telescope, with the help of which astronomers discovered our sandy brown dwarf, is an absolutely stunning piece of equipment. Around 100 times more powerful than Hubble. Even though the telescope itself is 3 stories high and its size equals that of a tennis court, its mirrors are the lightest large telescope mirrors of all time. When all the 18 mirrors of the telescope were completed during the manufacturing process, their mass was reduced by 92% in comparison to the initial discs. Each mirror weighed a mere 44 pounds. The telescope's mirrors seem to be gold, but in reality, they're made of beryllium, steel gray, lightweight, and brittle metal. There is indeed a gold coating on each mirror, but they can't be produced entirely out of gold since this material tends to expand and contract even with small temperature changes. That's why the total amount of gold in the James Webb Space Telescope is less than 2 ounces. James Webb's telescope side is cooling itself down, and its temperature doesn't rise higher than -370 degrees Fahrenheit. That's cool enough to make liquid nitrogen. A truly enormous 5-layered sun shield stretches around the telescope and reflects away as much sunlight as possible, letting the telescope stay cool. The telescope was launched near the equator because Earth spins a bit faster there, and this gave the rocket some extra push. The telescope orbits the Sun more than 1 million miles away from Earth, and when it runs out of fuel, it'll keep orbiting the Sun indefinitely. On the other hand, even though the telescope wasn't actually designed to be serviced or upgraded, it might potentially be refueled with the help of robots. This would extend its life. Anyway, if you think that our newly founded brown dwarf is the only bizarre exoplanet out there, let me show you some other breathtaking worlds. There is an exoplanet that is really something else. Just look at its awesome magenta color. You can find it in the Virgo constellation. The planet is called Gliese 504b. It orbits very far from its parent star, 9 times the distance between the Sun and Jupiter. The planet formed relatively recently and is still glowing with heat. That's why its surface looks pinkish. One of the oldest exoplanets we know about is about 12.7 billion years old. It's almost 3 times as old as Earth. This also means that the so-called Genesis planet formed only about 1 billion years after the Big Bang. The planet is so old that its two parent stars have had enough time to evolve into a white star and a pulsar, making almost 100 revolutions per second. I bet sunrises on this planet must look awesome. Just 20 light years away from the Sun, which isn't such a great distance when we talk about space, a bizarre rogue planet is roaming the Milky Way galaxy. But even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field. It's 4 million times stronger than Earth's. The exoplanet also produces amazing auroras. That's why when it was discovered in 2016, astronomers were almost sure they had detected a brown dwarf. But later, scientists got some proof that this space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet in the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptionally strong magnetic field helps the planet produce auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create mesmerizing light shows. The next exoplanet isn't like any other. It's often called Super Saturn or Saturn on steroids. That's because J1407b has a colossal system of rings. They're 640 times as large as those our Saturn has. This bizarre world is the only planet we know about that has rings similar to Saturn's. If you move this giant to our solar system and used it to replace Saturn, its rings would look many times larger than a full moon. An exoplanet called WASP-12b munches on the light coming from its star. It's one of the darkest worlds people know about. All because its day side consumes light rather than reflects it back into space. The egg-shaped planet is giant, twice the size of Jupiter, and it traps more than 94% of the light that reaches its atmosphere. It might be the main reason for the temperatures on the surface of the planet that can rise up to 4,600 degrees Fahrenheit. The night side of the planet isn't as hot as its day side, a mere 2,200 degrees Fahrenheit. The difference in temperature makes water vapor and clouds gather above the surface of the planet. And from time to time, swirls of material from the planet's superheated atmosphere spills onto its star. What of you? Discovered in 2017, KELT-9b is one of the hottest exoplanets we know of. The temperatures there can reach 7,800 degrees Fahrenheit. For comparison, the temperatures at the surface of the Sun reach 10,000 degrees Fahrenheit. The planet is probably so insanely hot because it orbits extremely close to its star, KELT-9, which is way hotter and bigger than our Sun. Experts believe that the giant star might one day evaporate the entire planet.
Psst, a giant is hiding in the sky. Quipu is the biggest thing we've ever found in the nearby universe. It's been messing with our understanding of the universe for years, and we've just discovered it. Quipu is dense, powerful, and dangerous to ignore. If we don't understand structures like this, we might be reading the universe completely wrong. So, what exactly is it? It's not a solid object like a planet or a star, and it's not a single thing. It's a superstructure, basically an entire region of the universe, a tangled mess of matter spanning a huge amount of space stitched together by gravity. Quipu is made up of an enormous web of galaxies, galaxy clusters or giant groups of galaxies, gas and dark matter. It's like a superhighway, with galaxy clusters being the cities, filaments being the roads, and dark matter being the invisible infrastructure holding it all together. This giant stretches across 1.3 billion light-years. That means if you traveled at the speed of light, it would still take you 1,003,000,000 years just to cross it. Quipu also holds 200 quadrillion solar masses, even though it only takes up 13% of the observable universe. The name Quipu comes from the Incan system of knotted cords used to record things, called quipus. It was like a writing system. In that system, each knot, color, and twist told a story: numbers, taxes, harvests, and so on. So, when astronomers saw this colossal structure in space, long, tangled, and branching like space cords, they named it after this language of knots. Plus, the shape of the space reminded scientists of those threads. There's a long central filament, and the smaller ones are branching off the sides. What's even more fascinating, Quipu isn't alone. When scientists mapped this part of the universe, they found 5 of these massive structures. They aren't just sitting there either. They formed over billions of years through gravity slowly pulling matter together. All told, all those giants hold nearly half of all the galaxy clusters in that region, 30% of all the galaxies, and a quarter of all the matter in the observable universe. The team that found Quipu used a clever trick. They searched for X-rays coming from galaxy clusters. These clusters aren't just full of galaxies, they're also filled with superhot gas. That gas is so hot it glows in X-ray light, which we can't see with our eyes, but special telescopes can. If there's a lot of that X-ray glow, it means there's a huge amount of matter, galaxies, gas, and dark matter all pulled together by gravity. That's where the densest, most crowded areas of the universe are. So, by following the X-ray glow, the scientists could draw a map showing where the biggest cosmic structures like Quipu were hiding. Why does any of this matter? Because these megastructures mess with everything. First of all, they warp the cosmic microwave background, the ancient light left over from the Big Bang. It's a faint glow of light that fills the entire universe. After the Big Bang happened and our world was created, it emitted its very first light and signals that still haven't completely weakened yet. The leftover radiation is still coming to us, even after 13.8 billion years. By studying this ancient light, scientists can learn what the early universe looked like, and Quipu ruins it for us. These megastructures hold so much gravity that they bend and distort this ancient light as it passes through them. That's called the integrated Sachs-Wolf effect. These warps add noise to the original signal, and now it's harder for us to get a proper, clearer understanding of what the baby universe looked like and how it expanded. They also mess with the Hubble constant. The universe is constantly expanding, and the Hubble constant tells us how fast it's growing. In other words, how quickly galaxies are moving apart from each other. But giant things in space, like Quipu, have so much gravity that they pull nearby galaxies toward them, messing up the way those galaxies move. This makes it harder for scientists to measure the universe's true speed of expansion. They can't tell if a galaxy is moving because of the universe growing or just because it's being pulled by something huge nearby. And finally, there's gravitational lensing. Light in space travels constantly, but it doesn't always follow a straight line. If the space gets distorted, like by gravity, then the light traveling through the space will get bent and distorted too. Gravitational lensing is when light from faraway galaxies gets bent because it passes by something supermassive, like Quipu here. That huge gravity pulls on the light, like how a heavy ball can bend a sheet. And since light delivers information to us, literally makes us see what things look like, this bending distorts how we see galaxies. The images of galaxies end up looking stretched, brighter, or we can even find an entire galaxy in the wrong place. It's like looking at our universe through a warped magnifying glass. If we're not careful, we could misread those distortions and get the wrong idea about what our world looks like. Luckily, we didn't just drop these mysterious superstructures out of nowhere. Astronomers suspected that something like that should be out there. They just didn't know for sure. Our best model for the universe is called Lambda CDM. It says, universe started with the Big Bang, is still expanding, and is mostly made of mysterious stuff, dark energy, and cold dark matter, the CDM part. We can't see or touch these things, but we know they exist, because if they didn't, our universe would literally break apart. This model matches what we do see, like galaxies forming, how stars move, and the overall shape of the universe. So even if some puzzle pieces by themselves are still a mystery, they match the actual picture. And this model actually predicted things like Quipu. When scientists ran simulations using that model, they saw similar structures forming, giant cosmic webs of galaxies tied together by gravity. Quipu matched those predictions in real life. This also means that Lambda CDM is matching real life once again, thank heavens. No huge surprises here. But now that we actually found it, it's the largest known structure in the observable universe. There was another giant before Quipu, the Sloan Great Wall. That one was discovered in 2003 and was believed to be one of the largest structures ever found. And it's still an absolute monster. The Sloan Great Wall stretches over 1 billion light-years across. It's called a wall, but it's not like a wall you'd find on Earth. It's also a vast cosmic web, made up of thousands of galaxies and gas connected by dark matter. What makes both Quipu and the Sloan Great Wall so surprising is that they literally seem too big to exist. According to the Lambda CDM model, structures that huge shouldn't be common, especially at the time they formed. How did these giants form so fast in a universe that's supposed to be growing, expanding, and smoothing over time? And if we keep finding more of them, that would be completely insane. It could mean there's something deeper going on in the way our world is built. It's all part of our crazy Copernican journey, a long series of discoveries where we just keep getting humbled by the universe. Every time we find something like this, we realize even more how we're not the center of everything. First, we learned the Earth wasn't the center of the solar system. Then we found that the solar system is just one speck in a galaxy. Now, even galaxy superclusters, which we believe to be the biggest, are being dwarfed by structures like Quipu and the Sloan Great Wall. But also, these structures won't last forever. Quipu is temporary. Over billions of years, gravity will tear it apart, breaking it into smaller pieces. Some parts will collapse into tighter clusters, others will drift apart. Right now, though, it's one of the most important structures in the known universe. It shapes how galaxies form. It bends light, making it super important for us to decipher. It literally messes with our understanding of the cosmos.
You're in your galactic space cruiser on your way to Outpost 52, delivering supplies for the small colony there, when alarms begin going off. You scan your displays, but something catches your eye before you can work out what's happening. You don't need a view screen, as the front section of your ship is transparent, like a one-way mirror. A colossal orange and purple cloud is sweeping towards you. There's no time to analyze it. You put the ship into a dive, as steep as it will go. The alarms go crazy, but you're too focused on getting out of danger. The ship rattles, and you think it will break up, but your ship is fast and powerful, and somehow you manage to get underneath it. You look up and see the gigantic plasma cloud go soaring past. Curiosity has bitten you, and you decide to follow it. You program your computer to analyze it. Soon the information is coming back, and you can't believe what it's telling you. This plasma cloud is a wrecker of galaxies. It and others like it have been ending galaxies before their time. You recall your studies back on Earth when you were just a young pilot. There have been studies as far back as the 21st century as to why galaxies were mysteriously ceasing the formation of new stars, causing them to end ultimately. Stars form from thick clouds of gas that have become extremely cold. They condense and, over time, collapse into solid compact matter. There's a famous photograph taken by the Hubble Space Telescope. Most people have seen it. It's called the Pillars of Creation. It's the Eagle Nebula, where stars are forming. They call these environments star nurseries. It's a pretty cute concept if you think about it. But there's a bad guy lurking, and you're following it. It's a vast star wrecker. The wrecker rushes in and sweeps the gas out of these star-forming galaxies at an accelerated rate, preventing stars from forming in the first place. It's like a giant broom. But rather than cleaning up, it's ceasing up, bringing new galaxies to a premature end. Now that you know how dangerous it is, it's best to hang back a bit. Let's see if we can see it in action from a safe distance. It had been a long-standing mystery why some galaxies don't birth new stars. The star wrecker is smart. It hangs around large galaxy clusters. There's one in particular, the Virgo cluster. This is the one that scientists studied and came across the star wrecker. The nearby Virgo cluster is 7 million light-years across and contains thousands of galaxies. When I say nearby, it's about 65 million light-years from us. Not exactly a weekend space cruise away, but it's pretty close in galactic terms. The cluster hurtles through the superheated plasma at speeds of up to 1,000,000 miles per hour. The cluster forms the basis for the large Virgo supercluster, of which the local group, where our Milky Way resides, is a member. Its proximity to us makes it easier for scientists to study. It's also one of the most extreme regions of the universe that we know of. Currently, who knows what else is out there? The Virgo cluster is also unusual, as it's still forming new stars, and we can observe them, such as in the famous Hubble nursery photo. A galaxy in this cluster is called the Messier 87. It was discovered way back in 1781 by a French astronomer named Charles Messier. It looked a bit fuzzy to him, so he called it a nebula without stars. More information on what it was couldn't be ascertained until the 1920s. Messier was well respected and in his lifetime discovered 13 comets. He was born in rural France, the 10th of 12 children. When he was 14, he witnessed a tremendous six-tailed comet in 1744. It was astonishing and was visible to the naked eye for several months. Its effects were dramatic and unusual. It was so bright that it's been recorded as the 6th brightest in history. 4 years later, young Charles saw a solar eclipse from his hometown on the 25th of July, 1748. He knew then that he wanted to explore the world of astronomy. It was meant to be. A lunar crater and an asteroid have been named after him. Nothing is mighty, however, like the Messier 87, or M87. It's a supergiant elliptical galaxy with trillions of stars. It's the second brightest galaxy within the northern Virgo cluster, making it popular amongst astronomers and amateur enthusiasts. Elliptical galaxies are older, low-mass stars with minimal star formation activity. Large numbers of globular clusters surround them. They make up roughly 10 to 15% of the Virgo supercluster. M87 has a supermassive black hole at its core. The black hole was photographed using data collected in 2017 by the Event Horizon Telescope, EHT. It was announced excitedly to the world in 2019. In March 2021, the EHT collaboration revealed a polarized-based image of the black hole for the first time. It was a pretty exciting event. It was the first time that a black hole had been captured. It happened all thanks to the Event Horizon Telescope, which is many radio observatories or radio telescope facilities around the world, all working together to produce a highly sensitive and high-resolution telescope. Another array of telescopes in Chile is called the Atacama Large Millimeter Submillimeter Array, ALMA. They captured high-resolution images of the 51 significant galaxies in the Virgo cluster. That's part of how we know what we know. M87 and other galaxies don't appear to be doing a lot to the naked eye. In fact, in a typical human lifetime, they barely move at all. Yet they are made up of gas, dust, and other objects that move through space at high speeds. They move when affected by the gravity of other galaxies, or dark matter, a mysterious entity that is 5 times more common than ordinary matter. Many galaxies, including our own, are believed to have a halo of dark matter surrounding them. The dark matter can pull more significantly on the smaller galaxies outside the clusters. As the galaxy gets dragged around through space, the star wrecker may come across. Giant clouds of intergalactic plasma, a form of electric gas, can behave like an atmosphere and drain the gas inside the galaxy. It sweeps out the gas inside the galaxy, stripping it of what it needs to make stars. It's hard to grasp the scale of this sort of activity, but that's what scientists now believe has been occurring to some galaxies or the nebulae without stars, as Charles Messier saw it. Now, let's park our space cruiser here and watch this thing in action. What we've been calling star wrecking is known as gas stripping. It's one of the most spectacular and violent external events in space. A scientist from the National Research Council of Canada said that galaxies are moving so fast through hot plasma in the cluster that a vast quantity of cold molecular gas is stripped from the galaxy. It's as though the gas is being swept away by a giant cosmic industrial blower. It's not the sort of clean-out we want to happen in our galaxy. You observe it in action. You're impressed, but equally respectful of its great power. The gas stripping, also known as ram pressure stripping, travels through many galaxies and removes a star-forming gas. The process is very efficient. The gas is behaving differently from the clouds in our galaxy. They aren't forming as many stars as they are in ours. A 21st century study found that the same process happens in smaller groups of only a few galaxies, with much less dark matter. The study looked at a staggering 10,567 satellite galaxies. These are galaxies that exist beyond the enormous galaxy clusters. Most galaxies in the universe exist in between 2 and 100 galaxies. They were able to study such a large number by using stacking. It makes it possible to learn about a collection of faint objects by combining all the information from the objects and making an average characteristic. They ultimately determined that gas stripping, or star wrecking, is potentially the main way that galaxies, predominantly star formation, are shut down by their surroundings. Pretty unfortunate to have such a nasty neighbor. So, now that your curiosity has been satisfied, it's best to leave this plasma cloud and get on with your journey to Outpost 52. You're going to be late now and could be in a whole lot of trouble. While the cruiser turns around, we'll head back to Earth. And back in time, back to 1744, to that night in rural France, where a teenager stood outside, marveling at the night sky and the spectacular vista of the six-tailed comet. And from that moment was inspired to begin a lifelong quest based on a single question, perhaps the ultimate of all: what's out there? In the heart of the galaxy, there lies a mysterious object, the likes of which no astronomer has ever seen. It streaks across the sky like a shooting star on caffeine. So, what is this mysterious blob? And how is it related to the black hole in the center of our galaxy? Let's find out. This thing is called X7. It's the mysterious blob that's been hanging around our galaxy's supermassive black hole for decades. Some even say it's been lurking around there for, like, hundreds of years. We know a few things about X7. For example, it weighs around 50 times as much as Earth. It may sound like a lot if you're an Earthling, but in space, that's like a tiny drop in the ocean. X7 is also moving pretty fast, at speeds of up to 700 miles per second. That's faster than you trying to catch the last slice of pizza before your roommate gets to it. But what in the world is this thing? A magic star we've never seen before? An extraterrestrial spaceship? Well, there are some theories connected to the blob's future tragic fate. Unfortunately, X7's days are numbered. Right now, it's on a 170-year-long elliptical orbit around the supermassive black hole at the center of the Milky Way. But it's not going to make it that far. Each year, it's spiraling closer and closer to the black hole. In just a few years, it will become spaghettified. Yes, that's a real scientific term. And finally get sucked in, never to be seen again. There are supermassive black holes in the centers of all galaxies, including our very own Milky Way. These black holes are so massive that they warp space-time, causing nearby stars to orbit around them at incredible speeds. They serve as cosmic vacuum cleaners that suck in anything and everything that comes close enough. The black hole in our galaxy is called the Sagittarius A star. Sounds like the name of a fancy Hollywood celebrity, doesn't it? But this celestial object is far more impressive than any mere mortal. It's about 4 million times more massive than our sun, which means it could probably eat our entire solar system for breakfast. But don't worry, these black holes may seem really scary, but in reality, they're too small to compete with an entire galaxy. They'll just suck in a couple of the nearest stars, and that's all. Also, Sagittarius A star doesn't seem to have a very good appetite. It's been observed to be pretty quiet lately, which is good news for us. But even if it were super greedy, it wouldn't pose any threat to us. This black hole is over 26,000 light years away. From Earth, we can see it in the Sagittarius constellation. In 2022, the Event Horizon Telescope collaboration released the first ever image of Sagittarius A star. It took years of collaboration and technology to capture this stunning image. And this is our second photo of a black hole in history. The first one was released in 2019, and it showed the supermassive black hole called M87 star. Yes, they both have star in their names. Don't try to make it make sense. Anyway, you may remember this photo as the first ever image of a black hole ever. It went crazy viral across the internet. And this black hole, M87 star, located in the Messier 87 galaxy, is way scarier than Sagittarius A star. You thought 4 million solar masses is impressive? Then how about 2.5 billion solar masses? M87 is a real monster. It's also known for its powerful jets of plasma, which are so energetic that they extend thousands of light years from the black hole's center. If M87 were a superhero, it would be Iron Man, with his repulsor beams on full blast. Now technically, you can't take a photo of a black hole itself, since it's, well, black. No light can escape its grasp. But the glowing orange ring in this photo shows the matter surrounding Sagittarius A star. It's called the accretion disk, a swirling disk of hot gas that spirals the center, heating up to millions of degrees in the process. It's like a giant fiery vortex, but with no escape. And the shadow in the center indicates the black hole itself. Inside that shadow, there's an event horizon. The event horizon is the boundary around the black hole, beyond which nothing, not even light, can escape its gravitational pull. It's the point of no return, where the gravitational force is so strong that even the fastest object in the universe, light, can't escape. Once you cross the event horizon, you're doomed to fall toward the center of the black hole, where the laws of physics as we know them break down. And this is exactly the fate that awaits our unfortunate X7. Right now, the pure blob is getting stretched and yanked by powerful tidal forces. By the way, before it meets its untimely demise, X7 is expected to put on a bit of a show. Its closest approach to the black hole, called periastron, is projected to happen in 2036. And when it finally gets torn apart by the Sagittarius A star's gravitational forces, there may be some cool fireworks to see. But this is not the most important thing. The funny part is, X7's future end may help us finally understand what the heck even is this thing. A team of scientists have been studying how a strange blob orbits the black hole. And that's when they discovered that X7 has stretched to almost twice its initial length. And what does that mean? Well, it suggests that X7 is most likely made of debris ejected during a recent collision between two stars. Yep, you heard that right, a space car crash. Imagine this. Two stars fall in love and start circling each other for many years. After that, they finally merge together. At this moment, they eject tons of gas and dust. And perhaps this cosmic dance created our blob baby, X7. It's basically like the crumbs left on the table after a giant space feast. Something like this is actually pretty common, especially around black holes. It's like a galactic fender bender that sends debris flying everywhere. Actually, the universe is full of mystery blobs. They're called the G objects. No, they're not the G-men from Men in Black, but they're just as mysterious and elusive. These guys have been puzzling astronomers for more than 20 years. They look like gas clouds, but behave like stars. It's like they can't decide whether they want to be a cloud or a star. Come on, guys, make up your mind. G objects stretch out at the closest point to the central black hole, but emerge intact, like a rubber band that stretches but doesn't break. Scientists think that they're the stars that have merged together into one. And while doing that, they also produce a huge cloud of gas that hides the result from view. Kinda like when you're wearing a bulky sweater, so that no one knows that you've put on a few extra pounds. And then a study published in 2021 found that one of these objects, G2, was actually a molecular cloud concealing 3 baby stars. Talk about a plot twist. But X7 is the black sheep of the strange blob family. It's significantly different from the G objects, like the weird cousin you see once a year at family gatherings. Its evolution has been more dramatic. Also, it's not being held together by a mass lurking in its center. So what is it being held together by? Pixie dust? Magic? We need answers! That's why scientists believe that X7 isn't a G object itself, but debris left from it. Or maybe not. We have no idea. The possibilities are endless, and that's what makes astronomy so exciting. So let's keep our eyes on the skies and see what other strange objects are out there. Who knows? Maybe we'll discover another mystery blob, and this time it's going to be a spaceship. Now that would be awesome.
The James Webb Telescope, or JWST, is like the ultimate intergalactic paparazzi. It takes pictures of some of the most famous celebrities in the universe. Stars, galaxies, exoplanets, you name it. The James Webb Space Telescope will snap a photo. So if you're a fan of cosmic celebrities, let's take a look at some of these best star-studded photos. The Carina Nebula. The image of the nebula with the beautiful name Carina was published on July 12th. JWST captured a beautiful view of the nebula, located about 7,500 light-years from Earth. Nicknamed the Cosmic Cliffs, it is, in fact, a hotbed of young stars, some of which are several times larger than our Sun. The Carina Nebula is a celestial spectacle located in the southern constellation Carina. It's really huge, approximately 260 light-years across. Massive stars within this nebula are so bright and hot that they create a glowing cloud of gas and dust around them. The Carina Nebula also contains swirling clouds of gas and dust where new stars are being born. The gas collapses under its own weight, becomes hotter and denser, and all this eventually leads to the creation of new stars. However, the Carina Nebula isn't just some peaceful place of star formation. It's the site of some of the most destructive events in the universe, which create massive shockwaves that obliterate everything in their path. Very chaotic and cool. The Stephan's Quintet. This photo was also posted on July 12th. Stephan's Quintet is a visual group of 5 galaxies located at a huge distance from us. About 290 million light-years in the constellation of Pegasus. It's like a cosmic family reunion. All these galaxies are related to each other and interact with each other in some interesting ways. They're pulling and tugging on each other with their gravity, constantly exchanging gas and dust. This interaction is causing some of the galaxies to collide and merge, which can create all sorts of cool effects, like bursts of star formation and supernovae. Thanks to JWST, we were able to see shockwaves, tidal tails, and other amazing details about these galaxies. Their interactions create a stunning sight that we can see in this photo. Jupiter. And here's our old giant friend. This image was published by NASA on August 22nd. Jupiter is the largest planet in our solar system, and it's known for its many moons and its beautiful swirling clouds. But it also has a system of rings, just like Saturn, which are made up of tiny particles of dust that orbit the planet. These rings are much smaller and less visible than Saturn's, but they're still pretty neat. Jupiter also has auroras, which are colorful light displays that occur in the planet's atmosphere. They're caused by charged particles from the solar wind interacting with Jupiter's magnetic field. Just like on Earth, they can be seen near the poles of the planet. But these auroras are much brighter and more intense than ours. We can even see this crazy light show from space. And now we were finally able to capture this dazzling sight. JWST's photo shows the auroras of Jupiter, its rings, and even two moons, Amalthea and Adrastea. It's amazing how bright and clear they are on this photo. The Cartwheel Galaxy. NASA released this image on August 2nd. This photo shows us the Cartwheel Galaxy and its companions. The Cartwheel Galaxy gets its name from its shape. It kind of looks like a cartwheel, doesn't it? This is a giant swirling mass of stars, gas, and dust, which is located in the depths of space. It's shaped like a pinwheel with long spiral arms. These arms are held together by the gravity of the central region, which is home to a supermassive black hole. But the Cartwheel Galaxy is a bit different from its spiral relatives. It has formed when a smaller galaxy collided with a larger one, creating a shockwave that rippled through the gas and dust. We'll definitely have to visit this galaxy someday. It's sure to be a wild ride. Spiral Galaxy M74. And here comes another spiral galaxy. NASA released this image on July 22nd. JWST had to peer through thick layers of dust and gas to see this beautiful star cluster. M74 belongs to a special class of spiral galaxies known as the Grand Design Galaxy. This means that its spiral arms are noticeable and clearly outlined. All sorts of amazing things are happening inside of spiral galaxies. Supernovas, stars being born in clouds of gas and dust, and many other cosmic wonders. The glowing gas and dust, the bright stars, and the swirling patterns of the spiral arms make them some of the most striking objects in the universe. Well, we can clearly see it on the example of M74. The Tarantula Nebula. This image of the nebula with a creepy name Tarantula was published on September 6th. The photo covers as much as 340 light-years across. This is a huge distance. Thanks to this image, astronomers have discovered new young stars that were previously shrouded in dust. The Tarantula Nebula is located 160,000 light-years away from us, in the Large Magellanic Cloud. It's the largest and brightest star-forming region in the local group, the galaxies nearest our Milky Way. It's named after its shape, which looks like a bit like the legs of a big tarantula. It's a vast region of space, about 1,000 light-years across, and it's home to some of the most massive and luminous stars in the universe. One of the reasons why the Tarantula Nebula is interesting to scientists is its composition. Its composition is close to the region of stars of the cosmic noon, the so-called state of our universe when it was only a few billion years old. At that time, star formation was at its peak. Thanks to the Webb Telescope, we can study this galaxy better and find out what our universe was like at its peak. Neptune's rings. This photo was published on September 21st, 2022. In this photo, we can even see 6 small moons next to the planet, with Triton shining brightly in the upper left corner. You didn't think it was the sun, did you? And yep, Neptune has rings too. They're like the ultimate cosmic accessory. They add a touch of glamour and style to the planet. But unlike some earthly bling, these rings are made of small particles of dust, rather than diamonds and gold. There are 5 known rings around Neptune: the Gall, Leverrier, Lassell, Arago, and Adam's rings. Scientists think that these are relatively young, much younger than our solar system, and much younger than, for example, Uranus's rings. They were probably created when one of Neptune's inner moons got too close to the planet and was torn apart by gravity. We haven't seen Neptune's rings so brightly since Voyager 2 flew past it back in 1989. So this is a great opportunity to take a closer look at these rings. The Pillars of Creation. This photo was published on October 19th. The Pillars of Creation became famous thanks to the Hubble telescope, but this photo is very lush and much more detailed. These columns, located in the Eagle Nebula, are about 5 light-years tall, which is really, really long. and they look like some majestic rock formations, only much more transparent. Just like a typical Hollywood movie set, they're full of action and special effects. They're home to some of the most dramatic processes in the universe. The gas and dust are collapsing under their own gravity, forming clumps that will eventually become stars. The place is full of intense radiation, jets of high-energy particles, and supernovae. It's like a cosmic version of Survivor. And if this wasn't creepy enough, here's another photo published by NASA on October 19th. They shared it right before Halloween. Here, the pillars resemble an eerie hand reaching for something. Bruh. Anyway, all these photos give us a truly awe-inspiring sight. They remind us of the incredible complexity of the universe and the amazing things that are happening even in the darkest and most remote corners of the cosmos. Let's hope that the James Webb Telescope will continue to amaze us in the future.
Black holes are ruthless. They can swallow asteroids, comets, planets, and even stars. But can a black hole consume the entire universe? Almost any black hole was once a massive star that collapsed in on itself and became incredibly dense. Black holes have immense gravitational pull. Even light can't escape their clutches. The idea that a black hole can swallow the universe is based on a common misconception. People often think that black holes work like vacuums, pulling space inside. But that's not the case. Black holes can only swallow stuff that is extremely close, usually space objects venturing into their event horizon. That's a black hole's point of no return. Once you cross this border, there's no escape. The event horizon for a black hole with the mass of our Sun could extend a mere 2 miles. If a tiny black hole had a mass of our planet, its event horizon wouldn't stretch for more than a couple of inches. It would be the size of your thumb, no more. But a black hole's gravity still affects the stars and planets surrounding it. It might make them orbit, just like the black hole at the center of the Milky Way galaxy does. But the hole doesn't swallow them. If our Sun somehow transformed into a black hole with the same mass, which is highly unlikely, Earth wouldn't feel any difference in the gravitational force influencing it. Our planet wouldn't change its orbit or hurtle toward the newly born black hole. Of course, it would get very dark and freezing cold, but being pulled inside a black hole wouldn't be a concern. Plus, most black holes are quite small. A black hole can only swallow a star if the said star is aimed almost directly at the black hole. Theoretically, it might happen. But according to space experts, for the Sun to get swallowed up by a black hole at the center of our home Milky Way galaxy, a truly enormous amount of time would be needed. After all, the star's orbit would need to line up with the black hole in a very precise way. Even the largest black hole in the universe that we know about, a space titan called Ton 618, seems to be near the theoretical limit of how large black holes can grow. This limit is determined by the fact that black holes release tons of radiation while developing. This radiation heats up and ionizes the matter surrounding the black hole, which makes it more difficult for the dust and gas to cool down and fall into the black hole. As a result, it slows down the rate at which the black hole can feed. We can probably say that this self-regulation stops black holes from gobbling down entire galaxies, let alone the whole universe. And we shouldn't forget about the expansion of the universe either. Objects in space move farther apart, which makes it less likely for them to collide or get captured by a black hole. If a black hole were to consume the entire universe, it would require a tremendous shift in the direction in which space seems to be moving. So, you don't need to worry that one day, our whole world will disappear inside a huge, universe-swallowing black hole. Unless, of course, the universe is already inside a black hole. I'm not kidding. There's a theory that we might be living in a black hole. Think about this. What if a black hole already engulfed us long ago? Surprisingly, some physicists deem this theory pretty plausible. For example, Dr. Nikodem Poplawski, a theoretical physicist from Indiana University, states that everything that a black hole swallows may turn into a new universe inside the hole or on the other side of it. So who knows? Perhaps our universe used to be quite a different place until it got pulled into a black hole.
Now imagine a place where a single day lasts longer than a whole year. On Venus, a day, meaning one full spin on its axis, is as long as 243 Earth days. And what's even weirder, despite the fact that Venus is experiencing a never-ending day, it has a shorter year than Earth. While Earth takes about 365 days to complete one orbit around the Sun, Venus does it in just 225 days. So, somehow, for Venus, a day is more epic than a whole year. Venus is a strange planet in general. It's called Earth's twin because of how alike we are, although it's a bit smaller than Earth. But there are some drastic differences too. For example, it spins in the opposite direction, which means the Sun there rises in the west and sets in the east. And Venus isn't the only one who dances to its own rhythm. Uranus does that too. And finally, Venus is quite crazy in terms of its atmosphere. When you stand on Earth, you don't really feel the weight of the air around you. Well, on Venus, that feeling would be like having an elephant sitting on your shoulders. Venus has 90 times the atmospheric pressure of Earth. The atmosphere there is a thick layer of toxic gases. For example, carbon dioxide that's released by all the volcanoes. It presses down with incredible force. This results in very hot temperatures. No wonder it'll take a long time before we'll be able to stand on this planet. Meanwhile, Mercury, the closest planet to the Sun, has an even more speedy orbit than Venus. It completes a full journey around the Sun in just about 88 Earth days. However, it has a slow spin on its axis, which means that one day on Mercury takes about 176 Earth days, basically half a year. Just like with Venus, a day there takes much longer than a year. Since it's closest to the Sun, no wonder Mercury experiences some super extreme temperature swings. Daytime temperatures can soar up to a scorching 800 degrees Fahrenheit, hot enough to melt lead. But wait for the sunset. At night, it drops to freezing minus 290 degrees Fahrenheit. Ooh! That's because Mercury doesn't have a thick atmosphere like we do, so the heat doesn't distribute across the planet evenly. If one side is in the dark, it'll be super cold, and the other side will be scorching hot, just like if you let a regular big rock lie down under the sun for a while. In fact, it's so cold that there might even be some ice on it. Look at the planet's North Polar region, especially those sunlit yellow spots inside craters. These are indications of water ice. Turns out water is much more common in space than we thought. Mars is often dubbed the Red Planet. It earns this nickname from the abundance of iron oxide, or rust, covering its surface. The iron-rich minerals create a rusty red hue that paints the Martian landscape. But it turns out Mars isn't just red. If you were standing on Mars, you'd witness desert-like butterscotch terrain with caramel and golden glows, some brown, and even a glimpse of a slight greenish hue. Mars also has the biggest mountain in the entire solar system, Olympus Mons, standing at a staggering height of about 13.6 miles tall. It's even taller than Mount Everest. It was formed by the volcanic eruption yielding low-viscosity lava, creating a shield-like structure. Since Mars is covered in sand, it's also famous for its crazy dust storms. But it turns out they're even more insane than we thought. These storms can last for months. While they might present challenges for future human missions, they also contribute to the planet's mesmerizing appearance when observed from afar. And not only storms, but even its own Mars quakes. Also known as seismic tremors, they were first detected by NASA in 2019. Unlike earthquakes that are often triggered by tectonic plate movements, Martian quakes are thought to result from the cooling and contracting of the planet's interior. It's interesting how similar, yet how different the planets are. Saturn's iconic rings might hold a secret link to Earth's ancient past. The rings are composed mainly of ice particles and debris and are estimated to be relatively young in space terms, perhaps just a few 100 million years old. Now, there are some theories that propose that they were born after some catastrophic event. For example, the collision of two large moons or the breakup of a comet. What's interesting is that this timeline coincides with the age of the dinosaurs' demise on Earth. Could there be a connection? Who knows? By the way, while Saturn takes the crown for its rings, it's not the only planet in our solar system sporting them. Jupiter, Uranus, and Neptune all have their own set of rings, although they might not be as visible and cool as Saturn's. However, there's something where Saturn truly stands out: the magnificent hexagon at its North Pole. It's a colossal six-sided figure. Each side of this incredible structure measures around 9,000 miles long, which is 1,200 miles longer than the Earth's diameter. Scientists aren't sure how it was formed or why. They think it might be due to varying wind speeds, or maybe it's shaped by a localized, slow, meandering jet stream. So far, it remains another of Saturn's mysteries. Much like Saturn's hexagon, Jupiter also has its own weird spot. It's called the Great Red Spot. This is a storm that's been raging for at least 350 years and is larger than Earth itself. Despite its name, the spot's coloration has varied over the years, ranging from brick red to pale salmon. Scientists continue to study this enduring storm, unlocking the mysteries of its persistence and ever-changing hues. Meteorologically, the Great Red Spot is a powerhouse. It generates enormous pressure in Jupiter's southern hemisphere. Meanwhile, Jupiter itself is a powerhouse when it comes to magnetic fields. Its magnetic influence is colossal. It extends far beyond the planet itself and creates one of the largest and strongest magnetic fields in our solar system. Because of that, Jupiter is a source of intense radiation and mesmerizing auroras. While Earth's northern lights are breathtaking, Jupiter has something to offer too. The magnetic field interacts with charged particles from Jupiter's moons and the solar wind. This creates visually striking auroras near its poles. But compared to Earth, the scale of these auroras is incredible, like nothing we've seen on our planet. But even having a cool big spot isn't a unique feature in our solar system. A stormy giant Neptune, the eighth and farthest planet from the Sun, also has its great dark spot. Just like Jupiter, it's a massive vortex in Neptune's atmosphere. But unlike its Jupiter counterpart, this spot tends to come and go because of Neptune's dynamic and ever-changing weather patterns. Neptune, together with Uranus, is known as an ice giant. And just like other giants, it boasts some of the most ferocious winds in our solar system. Its supersonic winds can get faster than 2,200 miles per hour. What a drama queen! But this explains its thick cloud formations. By the way, if you ever dreamed of a planet raining diamonds, you might want to visit this planet. Deep within Neptune's atmosphere, where pressures are extreme, scientists theorize that carbon atoms are compressed and form diamonds. And then, these diamonds might be raining down. What a unique touch to stormy weather. Neptune's moons got from their parent with the weird weather. For example, its largest moon, Triton, has a touch of cryovolcanism. Instead of spewing molten rock like Earth's volcanoes, Triton's cryovolcanoes erupt with a mix of water, ammonia, and nitrogen. Picture it as icy geysers shooting material into space. Seems like in our solar system alone, each planet has its own quirks and interesting qualities. Let's hope that we discover some more interesting things in outer space in the future.
Weird, unusual sounds out of nowhere are spreading all over our galaxy, constantly repeating, and it's something we've never heard before. Scientists discovered it in 2020, and it was nothing like any of the other energy signatures they ever studied. Powerful and bright radio signals occurring from time to time, mysteriously disappearing within a day. It doesn't fit the profile of any space body we know. The signal is a bit irritating, and it disappears without a schedule. When scientists tried to match the signal with some other telescopes, it was gone. Low-mass stars sometimes flare up with radio energy, but not here, since they mostly have X-ray counterparts. Very dense collapsed stars, like pulsars and magnetars, are also not a choice. The closest solution they got is a mysterious class of objects we know as the Galactic Center Radio Source, GCRT. It's a radio source that brightens and rapidly glows. It decays near the center of our galaxy and could help us unravel the mysteries of the universe. If you had a flying car that could go up at a speed of 60 miles per hour, you'd only need 1 hour to get into space. The moon is a little bit farther, 250,000 miles, which is about 10 times the circumference of our planet. That means a moon trip would be like taking a tour around the globe and doing it 10 times straight, which would take less than 6 months. A trip to Pluto would take over 800 years. Proxima b is the closest Earth-like neighbor we have. It's a small rocky world that orbits the closest stellar neighbor of our Sun. It orbits the star's habitable zone, an area that's far enough from any star to have moderate conditions, not too cold and not too hot for liquid water to at least hypothetically exist. If you tried to travel to Proxima b at a speed of 25,000 miles per hour, which is the speed of the Apollo moon rockets, it would take you over 112,000 years to get there. You might not be able to breathe there. No one knows if Proxima b has an atmosphere. Humans explore the universe all the time, but we can only see around 5% of the matter up there. And Albert Einstein was the first one that realized the empty space is not really nothing. The rest we can't see is actually made up of invisible matter, also known as dark matter. It's about 27%, combined with something called dark energy, which is 68%. If you try to pour water into space, of course, outside of a spacecraft, it would immediately boil away or vaporize. That's because there's no air or air pressure in space. As air pressure lowers, the temperature you'd usually need to boil water at also gets lower. Keeping that in mind, water boils way faster on a mountaintop than, for example, at sea level. There's no air pressure in space, so water could boil at a very low temperature. Scientists believe that there are at least a couple of billion galaxies out there. We don't know the real number, and probably never will, but they tried to calculate it by counting how many galaxies we can see in a pretty small and restricted area of the sky. It may seem as if the universe was filled with stars and a couple of planets here and there, but our home galaxy has at least 100 billion planets. If you fill a balloon with helium and release it, you'll notice it floats very high. It'll go up into the atmosphere, but it won't go into outer space. The higher you go, the thinner the air in our atmosphere gets. Your balloon will rise up until the point where the atmosphere surrounding it has the same weight as the helium inside it. That will happen at approximately a height of 20 miles above the surface, so this is as far as a helium balloon can rise. We don't really know how big the universe is. We can't see its edges, nor do we know if it even has an edge. We use technology to see out to a distance of around 14 billion light-years from our planet. This means we can see around 28 billion light-years in diameter across, starting with the outermost layer of our atmosphere that ends at around 600 miles above our planet's surface. Although the size of the universe is constantly changing and gets bigger through time. Mercury is closest to the Sun, so most people think it's the hottest planet too. Still, Venus is the hottest planet. It's the second planet away from our central star, around 30 million miles farther from the Sun compared to Mercury. Mercury doesn't have an atmosphere, which is like some sort of a warming blanket that helps maintain the heat coming from the Sun. Venus has an unexpectedly thick atmosphere, around 100 times thicker than the one we have. Its atmosphere doesn't let the heat out, it just keeps it, and constantly makes Venus hotter and hotter. Also, it mostly consists of carbon dioxide that freely lets solar energy in. But it's less transparent to lose long wavelength radiations that the warm, heated surface emits. The average temperature there is around 875 degrees Fahrenheit, which is hot enough to melt tin. The maximum temperature on its neighbor, Mercury, is 800 degrees Fahrenheit. In maybe 2 or more billion years, it will be way too hot for life to exist on our precious planet. As the hundreds of millions of years go by, our sun will keep getting hotter and brighter. Eventually, temperatures will be so high, our beautiful oceans will be wiped away. Since they produce 70% of the oxygen we need to survive, there'll be no life without them. All of this means that our planet will simply become a vast desert, something like Mars is today. Pluto, a very distant used-to-be planet, now dwarf planet, is actually smaller in diameter than the entire US. The biggest distance there, from Maine to Northern California, is approximately 2,900 miles, while Pluto is only 1,473 miles across. Pluto is very far, but the edge of our solar system is 1,000 times farther away than this dwarf planet. But astronomers found many space objects orbiting our Sun way farther than Pluto, such as Kuiper Belt objects and trans-Neptunian objects. There's also an Oort comet cloud that goes half a light year from Pluto, also 1,000 times farther. A neutron star is really heavy. Just a teaspoon filled with it would weigh 6 billion tons. Neutron stars are something that remain from huge stars that have run out of fuel. The fading star explodes, and its core falls apart, but due to gravity, it forms an extremely dense neutron star. These stars typically have a mass of up to 3 suns, but the radius there is around 6 miles, because this is one of the densest things in our universe, at least that we know about. The universe has a color, and it averages to be some kind of beige, or as they call it, cosmic latte. It also has its own smell that reminds you of seared steak or hot metal. At least, that's something astronauts floating in space have said. If you want to build a spacesuit, get ready to work really hard. It takes 5,000 hours to make it and will cost you $1 million. A really good one will have 11 layers of material and weighs about 110 pounds, and it needs to be comfortable. You'll need more space in there because you grow up to 2 inches when in space. When you're floating around in space, Earth's gravity doesn't have any impact on you. That's why the vertebrae in your spine might expand and relax a little bit, which means you'll be maybe 3% taller. For 6 feet, it's about 2 extra inches. Oh, don't worry, it's not permanent. As soon as you go down to Earth, you'll shrink back down to your normal size within a couple of months. Space isn't the best option if you want to have a conversation with your friend, because up there, sound doesn't travel at all. Molecules there are so far apart that sound vibrations can't reach them, which automatically means they can't vibrate, so we can't hear them. Movies are not accurate with this. No one could hear you screaming in space, too. We kind of live inside our sun. The sun is not just that big hot ball of light located 93 million miles away from us. Its outer atmosphere is way bigger. It extends far beyond the surface we can see. Our planet's orbit goes through its tenuous atmosphere. The evidence is when gusts of the solar wind generate the southern and northern lights. That means, in some way, we live inside the sun. Not just us, other planets too, including distant Neptune. The heliosphere, which is what we call the outer solar atmosphere, extends to about 10 billion miles.
It's been more than a year since the James Webb Telescope, which had taken over 20 years to complete, was launched. And for such a relatively short time, the ultra-modern and most powerful in history piece of equipment has already made plenty of discoveries. By observing the universe at infrared wavelength, James Webb lets us see things no other telescope has ever shown before. The primary goal of this incredible piece of equipment is to study the formation of galaxies and stars that appeared in the early universe. For example, look at the closest to us stellar nursery, a region of space where new stars get born. NASA has shared an image from James Webb that shows a small star-forming region. If you look at the picture attentively, you'll see jets bursting from infant stars. Around them, different colored clouds of cosmic dust are colliding with one another. The view is mesmerizing. The red dust consists of molecular hydrogen. You can also notice that some stars have something like shadows. Those hint at the creation of what will later become planets. At first sight, the image may seem chaotic, but astronomers claim that it's a relatively small and quiet stellar nursery in comparison to some others. Many young stars there are similar in size to our Sun, or a bit smaller. The photo itself was taken with the help of Webb's near-infrared camera, NIRCam. It's the observatory's primary camera that snaps images of the cosmos in 2 different infrared ranges. Another amazing discovery the Webb telescope has made is smoke molecules in a distant galaxy. It's the first time such molecules have been discovered so far away from our planet. The galaxy in question lies 12.3 billion light-years away from Earth. It most likely formed about 1.5 billion years after the Big Bang. Despite such a huge distance between the galaxy and our planet, scientists have managed to detect chemical compounds found in soot or smoke, and it's quite a big deal since it has pushed the record for detecting similar complex molecules back by around 1 billion years. This study has also confirmed the sheer power of the coolest piece of space equipment of all time. It managed to make this discovery despite the fact that the spectrometer needed for the measurements didn't perform to the fullest after having experienced a sudden and surprising degradation. The James Webb Telescope has also helped to boost our understanding of exoplanets. Those are planets orbiting stars other than our own sun. At the beginning of 2023, the observatory spotted its first exoplanet, LHS 475b. It's located 41 light-years away from Earth and is approximately the same size as our planet. According to NASA, nowadays, James Webb is the only operating telescope capable of categorizing the atmosphere of Earth-sized exoplanets. The research team behind the discovery believes such results underline the precision of the telescope. They hope that it will help us locate many more rocky exoplanets that we might be able to colonize in the future. Even though, at first sight, it may seem that the universe is pretty empty, it's actually a very busy place. And Webb has all the necessary instruments to see all kinds of cosmic events happening out there. Just look at this image of WR 124. It's a star on the cusp of its explosive demise. In the image, the star is about to go supernova. It happens when a star runs out of its fuel and explodes at the end of its life cycle, releasing a giant cloud of space dust and hot gas into space. The star captured by the Webb telescope was at the Wolf-Rayet stage of its life. That's a period when a star is shedding its outer layers before going supernova. The next amazing thing discovered by James Webb is a star-planet hybrid with very strange clouds. This bizarre world, VHS 1256b, is actually a brown dwarf. Those are bigger than planets but too small to classify as stars. They emit some light of their own and are quite hot, but their mass is simply not enough to fuse hydrogen into helium like full-fledged stars do. Space bodies of this kind aren't actually brown. They occur in a wide variety of colors, but those are mostly invisible to the human eye. What we can see is the light they emit, and to us, it appears to be dark orange or magenta. The brown dwarf discovered by the Webb telescope is almost 20 times the size of Jupiter. It orbits 2 red dwarf stars, and to complete one orbit, it needs over 10,000 years. Astronomers first found out about this unusual exoplanet in 2016, but at that time, they didn't classify it as a brown dwarf, and, thus, couldn't explain its puzzling reddish glow. Now, thanks to the James Webb Telescope, they know the space object's origin. Anyway, back to those clouds. As you know, clouds on Earth are made of water vapor, but those on the brown dwarf are different. They seem to be made of sand. It looks like good old sand from Earth, but it's actually not. The clouds are made of tiny particles of silicate. Another recent discovery involves several large galaxies that scientists believe were born not long after the Big Bang. They aren't supposed to be there, and no one expected to find them. But the James Webb Space Telescope has spotted them. These galaxies, as massive as our home Milky Way, are full of mature red stars. Astronomers have analyzed the light coming from them and estimated their age 500 to 700 million years after the Big Bang. It means that they came into being when our universe was very young, almost a baby. But the most bizarre thing about these galaxies is their tremendous size and the age of the stars dwelling there. The data received by the telescope don't coincide with the existing ideas about what the universe looked like and how it evolved in its early years. It also doesn't match the earlier observations made by Hubble. And here, James Webb has captured a distant region of space in unprecedented detail. This section of space is known as Pandora's cluster. In the image, you can see three massive clusters of galaxies coming together and forming a megacluster. The combined mass of these clusters acts as a powerful gravitational lens. And thanks to this natural magnification effect, scientists can see other galaxies in the region. Astronomers claim that the most recent image of Pandora's cluster is stronger and deeper than they have ever seen. James Webb has also managed to spot thousands of young stars never seen before in the Tarantula Nebula. This space formation got its nickname because of the appearance of dusty filaments spotted in previous images. It's the biggest star-forming region in the local group, which includes the galaxies nearest to the Milky Way. The Webb Telescope's images have helped to shed light on the composition of the Tarantula Nebula. The telescope has also detected protostars, infant stars in the process of gaining mass. Astronomers expect that these protostars will eventually form and shape the nebula further. Among other discoveries made by the James Webb Telescope, you can see the birth of 50 distant stars. Some of them power protoplanetary disks, which might later form solar systems light years away from our own. Here's one more image from James Webb. You can see a supermassive black hole that has a mass of 9 billion suns. It's so ginormous and ancient that scientists are struggling to explain its existence. Astronomers have also discovered a distant ring of dust, rock, and gas that contains a chemical called methylcation. It's known as a molecular building block of life, and it makes most of the organic material on our planet. James Webb helped researchers see powerful sandstorms on a planet 235 trillion miles away. Astronomers were happy to discover this treasure chest of countless tiny sand particles. Now look at this. Do you recognize this image? Those are the so-called pillars of creation. But this new view shows us just how star-speckled that dusty region actually is. You can compare the new photo with the one taken by Hubble in 2014. This is astonishing proof of scientific progress.
Bang! Or should I say, Big Bang? The Big Bang. Ahem. So, after the Big Bang, the universe resembled a hot soup of protons, neutrons, and electrons. After it started to cool down, the protons and neutrons began to combine, first forming ionized atoms of hydrogen and later some helium. These ionized atoms of helium and hydrogen attracted electrons, turning them into neutral atoms. As a result, the light was able to travel freely for the first time ever, since it was no longer scattering off free electrons. What does it mean? The universe was no longer dark. At the same time, it was still about a few 100 million years after the Big Bang before the very first sources of light started to appear. That's when the cosmic dark ages came to an end. We don't know for sure what this universe's first light looked like or how the first stars formed. Luckily, we have the James Webb Space Telescope to help us find the answers. How come? All because this is an infrared telescope. Why is it important? Let's figure it out. Imagine a star. It's a very, very old star, maybe the first star out there. Light leaves this star 13.6 billion years ago and settles off on an incredible journey through space and time. It needs to get to our telescopes. By the time this light reaches us, its color or wavelength shifts towards red. That's something we call a redshift. It happens because when we talk about very distant objects, Einstein's theory of general relativity comes into play. According to it, the expansion of the universe also means that the space between objects stretches, making them move away from one another. But that's not all. Light stretches too, which shifts it to longer wavelengths. Eventually, this light reaches us as infrared. In other words, redshift means that light that is originally emitted by the first stars or galaxies as ultraviolet or visible light gets shifted to redder wavelengths by the time we catch a glimpse of it here and now. For the farthest objects with very high redshift, that bare minimum of visible light is shifted into the near and mid-infrared part of the electromagnetic spectrum. That's why to see those space objects, we need a super powerful telescope. And if we talk about the Webb telescope, it can see back to about 100 million to 250 million years after the Big Bang, which is incredibly awesome. So by observing the universe at infrared wavelength, James Webb lets us see things no other telescope has ever shown before. The primary goal of this incredible piece of equipment is to study the formation of galaxies and stars that formed in the early universe. To look that far back in time, we need to look deeper into space. All because it takes light time to travel back from there to us. So the farther we look, the further we glimpse back in time. To find the first galaxies, James Webb is going to make an ultra-deep near-infrared survey of the universe. Then it'll follow it up with a few other methods of research. Now, as you remember, the gas between stars and galaxies in the early universe was opaque, and energetic starlight couldn't penetrate it. But then, about 1 billion years after the Big Bang, it suddenly became completely transparent. Why? The James Webb Telescope might have found the reason. At one point in the past, the first galaxy's stars emitted enough light to ionize and heat the gas around them. This helped clear the view over hundreds of millions of years. The newest insights scientists got were about a time period called the era of reionization. That's when the universe underwent some dramatic changes. After the Big Bang, gas in the universe was unbelievably hot and dense. Hundreds of millions of years passed, and it cooled down. But then, something baffling happened. It was as if the universe hit the repeat button, and the gas became ionized and hot once again. It could have happened because of the formation of early stars. After that, millions of years later, this concoction became transparent. For a long time, researchers have been hoping to find definite evidence that could explain these changes. And now, the telescope has finally shown that those transparent regions are located around galaxies. Astronomers have seen these galaxies reionize the gas surrounding them. Even better, they've managed to measure how large these transparent regions are. They're ginormous compared to the galaxies themselves. Imagine a hot air balloon, and now imagine a pea floating inside. You've got it, and guess what? These tiny galaxies drove the entire reionization process, clearing huge regions of space around them. These transparent bubbles kept growing until they merged and caused the entire universe to become transparent. The research team chose to target a period of time before the end of the era of reionization. At that time, the universe was not quite opaque, but not quite clear either. It was a patchwork of regions of gas in different states. To find out this cool fact, the astronomers aimed the James Webb Telescope in the direction of a quasar, an incredibly bright space object. It acted as a giant flashlight, traveling towards us through different regions of gas. It was either absorbed by the patches of near opaque or moved freely through the areas where the gas was transparent. The scientists then used Webb to examine galaxies in that region of space. They found out that these galaxies were usually surrounded by transparent regions with a radius of about 2 million light-years. For comparison, the area the galaxies cleared was almost the same distance as the space between our home Milky Way galaxy and our nearest neighbor, the Andromeda galaxy. And the telescope witnessed those galaxies in the process of clearing the space around them. It was the end of the era of reionization. Until then, no one had evidence of what caused reionization. The team is planning to dive into research about other galaxies in 5 additional fields. The Webb Telescope's results from the first field have been overwhelmingly clear. And even though the astronomers had expected to identify a few dozen galaxies existing during the era of reionization, they actually managed to spot 117. Now, let's talk a bit about the main hero of today's show, the James Webb Space Telescope. It's an absolutely stunning piece of equipment which is around 100 times more powerful than the Hubble Space Telescope. And the latter has observed places that are 13.4 billion light-years away. The James Webb Telescope is also on the pricey side, to put it mildly. even though originally the cost of the telescope was estimated to be just $1 to $3.5 billion. The whole development process cost around $10 billion. For comparison, it cost NASA $4.7 billion to build and launch the Hubble telescope, and it was another $1.1 billion to fix it in orbit. Even though the James Webb Telescope itself is 3 stories high and the size of a tennis court, its mirrors are the lightest large telescope mirrors of all time. During the manufacturing process, they underwent a 92% reduction in weight. When you look at them, the telescope's mirrors seem to be gold, but in reality, they're made of beryllium. This is a steel gray, lightweight, and brittle metal. A gold coating is applied to each mirror, that's true, but they can't be produced entirely out of gold, since this precious metal tends to expand and contract, even with small temperature changes. So the total amount of gold in the James Webb Space Telescope is less than 2 ounces. That's a golf ball-sized piece of gold. And the gold plates covering the mirror are less than 1,000 atoms thick. As for the telescope's abilities, it would be able to clearly see a US penny from 24 miles away and a football from 340 miles away. James Webb's telescope side is cooling itself down, and its temperature doesn't rise higher than minus 370 degrees Fahrenheit. That's cool enough to make liquid nitrogen. A truly enormous 5-layered sun shield surrounds the telescope and reflects away as much sunlight as possible, letting the telescope stay cool. Hey Mythbusters! Today we're debunking some classic space myths. Hop on the next space shuttle and let's get to the bottom of these tales once and for all. Picture this. You're floating weightlessly in space, sipping on a cup of delicious hot chocolate, when a peculiar thought pops into your head. Can you scream in outer space? And if yes, would anyone hear that scream?
If you've watched the movie Alien, then you know the answer to this one. You can't hear sounds in outer space.
It's not that sounds don't exist.
It's just that you can't hear them.
There's no one better to clarify this myth than Chris Hadfield. He's been on a couple of spacewalks during his life as an astronaut. And once you're out there in the darkness of space, you can't hear anything.
All you hear is silence. Complete silence.
But hey, just around the corner is a massive ball of explosion, aka the sun. We just can't hear the explosions happening because there's no medium for sound to travel through. It would be quite uncomfortable for an astronaut, though, if they could hear all the noises going on in outer space. Now, imagine you're zipping through space, feeling like a futuristic superhero, when a shooting star passes by your side. But wait, is it really a star? Unfortunately, shooting stars are not stars at all. They are small space rocks known as meteoroids, entering Earth's atmosphere and creating a stunning light show. Oh, and since we're debunking myths, let's head straight for another one. You've probably heard that meteors only crash into Earth on extremely rare occasions, like once every dinosaur extinguishing apocalypse. That's not true. Scientists estimate that about 48 tons of meteoritic material fall on Earth each day. But almost all of this material is vaporized in Earth's atmosphere. The bright trail we see in the night sky is what we popularly call a shooting star. Next time you make a wish upon a shooting star, remember, you're actually hoping on a tiny piece of space debris. It's not so romantic after all. Can we or can we not fly into the stratosphere on air balloons? Apparently, we can. The Earth's stratosphere starts relatively close to the ground, about 7 or 8 miles up from the Earth's surface, but it continues a long way up. If you were to fly yourself all the way into the stratosphere with some type of air balloon, just make sure you have really good equipment at hand. You'll need a special suit and some breathing devices because air starts to get pretty thin the higher you get. Of course, if you do go all the way up, you need to get a picture of the Earth's curvature. So take a chest harness with you where you can put a special camera or something like that. And how about you live stream the whole thing? That would be a first. Imagine it's been 102 days since you left Earth. You've adapted well to life in outer space, but something weird is happening to your body. You're getting taller. How is that even possible? Don't stress about it, it's completely normal. The truth of the matter is, you're not getting taller. This is what happens to your body when it's not under the effect of gravity. Our body has natural space between vertebrae and joints. On Earth, this space is almost completely squeezed due to the force of gravity. But in space, your body gets some time off of the pushing force of gravity and begins to stretch more and more. So yes, astronauts can grow up to 3% taller when they're on long missions. And here's a curiosity, NASA has that all covered when they're tailor-making spacesuits, of course. This way, astronauts will always have extra space in their suits. Once astronauts are back on Earth, the anti-gravity effect will wear off. So maybe they'll spend a few days wearing capri pants before it fits perfectly on their bodies again. Never have I ever pictured an airplane door bursting open mid-flight and a bunch of passengers being sucked into the atmosphere like flying feathers. Well, I'm betting most of you have had similar thoughts when getting inside a plane. Now imagine if this were to happen in outer space. Common knowledge says that if an astronaut is sucked out of an airlock, this person would be burnt to a crisp. Brace yourselves, because this is not only true, but the reality of it is way worse. According to astronaut Chris Hadfield, this is what would happen. The part of your body in the shade of the sun would experience temperatures of -418 degrees Fahrenheit, while the part of you getting sunlight would burn at around 480 degrees Fahrenheit. Your lungs would collapse, and your blood would start to boil like tea water. So you would burn, freeze, lose your ability to breathe, and boil. Yikes! How many times have you heard that astronauts have to work out every second of every day, otherwise they'll pass out? This is a complete myth. Remember we talked about gravity earlier? Due to the lack of gravity in outer space, our bodies don't have to do any heavy work. Our torsos don't have to sustain the weight of our heads, and we don't have to make any effort to move our legs because, essentially, there's no walking in outer space. Now imagine living like that for 6 months, or even a year of your life. Your muscles could turn into jello. That's why astronauts work out. They'll strap themselves and run on a treadmill, or they'll do some weightlifting in a special machine. This way, their muscles won't feel the lack of gravity too much. They do need to keep hydrated though. You know what? If I was an astronaut, I'd ask NASA if I could take my super soft water flask up into space with me. You've probably heard that space smells like burnt steak or barbecue sauce. Now, as much as this sounds absurd, this myth is more true than it is false. Astronauts obviously can't smell space when they're in it because they can't take off their helmets. They usually smell it once a space vehicle docks and they open up a hatch. Apparently, what causes this smell is the presence of hydrocarbons that float around in space. Who would have thought, huh? Hey smart people, let me ask you a question. Do you really think that if astronauts fly at the speed of light, they won't age a single second? I knew you'd say no. Let's get a few things straight. First of all, we haven't figured out how to operate vehicles at the speed of light. This would require an immense amount of energy, and we don't have the technology to do that. Second, even if we managed to send a human inside a spacecraft that traveled at the speed of light, this person would still age. They would age differently than the people who remained on Earth, that's a fact, but they would still age. Do you lot really think there's such a thing as immortality? Nah. If you've seen the first Avatar, then you certainly remember that humans only managed to get to Pandora because they traveled in Cryosleep. In other words, they froze their bodies, put them in a cryobed, and traveled for years without aging. Yes, this sounds amazing, but we still don't have the technology to do that. Our bodies are mainly made out of water, right? And when you freeze water, it expands. That's why you should never leave soda cans unattended in your freezer. Right now, if we froze a person's body, the water inside of it would expand, harming tissues and organs. So no, we can't cryosleep our way into interstellar travel. Not yet, at least. Here's a crazy thought. What would happen if an astronaut took a drone with him on one of their spacewalks? Unless it's a NASA-designed drone, maybe the thing would freeze and burn like humans would if they went into space without a suit. But hey, a person can dream, can't they? Space is a dangerous place. It seems like wherever you go, something tries to get rid of you. So what if you wanted to go up there without a spacesuit? What's good is that your body probably wouldn't explode. Your skin is strong and stretchy enough to deal with all that pressure. You wouldn't freeze right away either. In space, the only way for your body to lose heat is through radiation, which happens very slowly for a relatively cool object like a human body. You would eventually get cold, but it would take a while, or your fluids would evaporate. Keep your eyes closed if possible. Okay, the air would be the first emergency problem here. Your brain wouldn't be able to get oxygen, so you'd pass out within 15 seconds, and within 3 minutes your brain would shut down forever. If someone rescued you within the first 30 seconds, you might only have some bruises on your skin from all the pressure changes. Hopefully you didn't try to hold your breath before they catapulted you out there though. In that case, the air in your lungs would cause them to rupture, which again wouldn't be a happy end. But here's a spot where no one would be able to save you: the center of the galaxy. Each galaxy has a supermassive black hole at its center, and these are even worse than you might expect. They eat up a bunch of matter and release an enormous amount of energy. The largest of these gobblers and the hungriest among them are something we call quasars. Well, to be precise with the relations here, quasars actually contain supermassive black holes that eat everything in their way. And these quasars are some of the most energetic space objects that we know about. When something falls into a quasar, it gets really hot and shoots outward at very high speeds because of the strong radiation force. Quasars can deceive you if you try to observe them through a telescope because you might think you're looking at stars. Astronomers also named them quasi-stellar radio sources because the signals were coming from one place, similar to how it goes with a star. But quasars, of course, have a stronger light. They can shine much brighter than a galaxy with billions of stars. But this same radiation that makes them so bright is not such good news for the galaxies where they're located, because these guests are not very polite and they're slowly ripping them apart. Okay, maybe not that slowly. As a black hole eats matter, hot gases circles around it and produces very intense radiation, which then creates a quasar. Scientists use the famous Hubble Space Telescope to study 13 insanely powerful quasar outflows of radiation. This energy can travel at speeds over 40 million miles per hour and reach temperatures of billions of degrees. One particular outflow of radiation they studied got faster and went from nearly 43 million miles per hour to about 46 million miles per hour in only 3 years. The energy these outflows carry is several hundreds of times stronger than all the light our entire Milky Way galaxy emits. And all this hot gas is moving so fast that it can really cause a lot of damage to the host galaxy. It rushes through the galaxy like a massive tsunami, faster than anything we've previously discovered in space. At the same time, it's pushing apart all the potential material that could get together and form new stars. In just 1 year, this quasar wave can push away as much matter as hundreds of suns and create spectacular fireworks. I mean, the light show would be cool, but that seems like an awful lot of wasted material. These things we're discovering can really help us answer the question that's been bothering us for such a long time. Why do big galaxies stop growing after they reach a certain mass? No wonder when the quasars don't even allow new stars to be born. How rude! I mean, a black hole itself can't destroy the whole galaxy. When a star gets too close, a black hole will tear it apart with its strong gravity. This creates a lot of energy and a bright flare too. And even though we can't really see a black hole itself, scientists can at least study these flares. They can measure their energy more accurately than ever before because they look at how the surrounding dust absorbs and re-emits the light from the flares. It's actually similar to how echoes work. Scientists have also used NASA's Chandra X-ray Observatory to study more than 100 galaxies and realized these black holes are consuming thousands of stars, so they could gain more weight. There are different types of black holes. We call smaller ones stellar mass black holes. They're about 5 to 30 times the mass of our Sun. On the other end of the scale, there are supermassive black holes that nest in the centers of large galaxies and weigh millions, or even billions of times the mass of the Sun. And recent research tells us there are intermediate mass black holes, which lie in between the two extremes. And it seems these intermediate black holes could be small black holes that had been eating lots of stars, becoming bigger. The special buffet a black hole just can't resist is when there's a dense cluster of stars in the center of a galaxy. Yum! So yeah, black holes are mean fellas, but there's still no way they could eat a whole galaxy. A black hole's gravity is just not strong enough, unless there's a quasar around, making its force stronger. Don't worry though, quasars are usually billions of light years away from us. That means we see them as they were billions of years ago, because light takes time to travel. And light years represent the amount of time necessary for that. It's great that we can study quasars, not because they're pretty cool, terrifying, but still cool, but because with their help, we can learn more about how our own galaxy formed and developed. Quasars are part of a larger group of objects called active galactic nuclei. This family tree also includes Seyfert galaxies and Blazars. These are not as awesome as their cousins, but okay, we'll give them a short introduction. Seyfert galaxies may look normal in regular images, but they emit a lot of infrared radiation, radio energy, and X-rays. Basically, they're similar to quasars but release less energy, and they have supermassive black holes at their centers too. Copycat. Blazar and Quasar sound pretty similar, huh? Still, they're a bit different. The story of a blazar starts in a familiar way. At the center of a galaxy, there's a giant black hole surrounded by a disk of dust, gas, and debris that spins really fast. As the material in the disk falls towards the black hole, its gravitational energy can end up being converted to light. This makes the center of these galaxies very bright, and we call them active galactic nuclei. Some of these active galactic nuclei are not fine with just shining bright, so they shoot out jets of material that nearly reach the speed of light. This is a quasar. But when a galaxy happens to turn so that the jets point towards our home planet, it's what we call a blazar. And yes, it's like Earth is staring down the barrel of a cannon. Quasars and blazars emit jets of particles pointing towards us or in our direction. Scientists believe Seyfert galaxies are different because they emit jets pointing away from us, which is why it's harder to detect them. These jets from blazars can release particles with lots of energy that we call neutrinos. A couple of years ago, scientists discovered a single neutrino that traveled from a supermassive black hole in a blazar located about 4 billion light-years away. This was so exciting because we've captured neutrinos from only 3 cosmic sources so far: our Sun, a supernova, which was a powerful explosion that happened in a nearby galaxy in 1987, and now from the blazar.
Guess what? Scientists have come up with a cool idea about some cosmic creatures saying hello to us from the center of the Milky Way. Astronomers are all excited about finding extraterrestrial life, so they're focusing their search right at the heart of our galaxy. Imagine stars in outer space, like super cool DJs, spinning their own unique beats. But instead of music, they send out these special signals called radio pulses. It's their way of saying, "Hey, what's up, universe?" These radio pulses are basically little bursts of energy that travel through space. They're not just random noise, though. They have a specific pattern that makes them stand out from all the other sounds out there. It's like a secret code or a special rhythm that only these stars know how to create. Scientists are super curious about these radio pulses because they think that maybe, just maybe, intelligent beings from other planets could be using them too. It's like a galactic language that they could use to talk to each other. So, these clever scientists created special tools and software to listen in on these signals. It's kind of like tuning into your favorite radio station, but instead of music or talk shows, they're trying to catch these cosmic beats. They're hoping to find those unique patterns that could be a sign of other space beings trying to communicate with us. They used a super cool telescope called the Green Bank Telescope in West Virginia to collect data and search for these signals. But here's the twist. They didn't find anything this time. No worries though, because their fancy software is lightning fast and it'll help them search even better next time. But why did they pick the center of the Milky Way for this ET life hunt? Well, that's because the galaxy's hearts are packed with stars. In other words, there should be many more planets in there, which means more potential places for life. Plus, if there are super smart life forms at the core of our galaxy, they could easily send signals to lots of planets all at once. Sneaky, huh? This whole thing is super exciting because it's the first time scientists have gone all out to search for these types of signals. They think that using specific frequency ranges and repeating patterns is a really clever way for ET beings to make themselves known. I mean, that combo is so unlikely to happen naturally, right? The best part is that they have this algorithm thingy that can go through a crazy amount of telescope data in just 30 minutes. So, even though they didn't find anything yet, they're confident that this speedy method will help them find evidence of advanced life in the future. How awesome would that be? As you know, humanity has been searching for buddies from outer space for a very long time. This research is just one of many attempts to find them. There's a whole institute dedicated to this mission in the US, SETI, or Search for Extraterrestrial Intelligence. So, naturally, the question arises, why haven't we found anyone yet? It's like we've been scanning the sky forever, hoping to catch a glimpse of advanced civilizations out there. But we get absolutely nothing. All this brings us to the famous Fermi paradox. It's like a big mystery that fuels the hunt for extraterrestrial intelligence. We'd think that if intelligent life exists, we'd have evidence of it by now. Maybe they're actually beaming out radio signals for us to pick up. Or maybe they're just broadcasting in general and we happen to stumble upon it. They could even have left cool artifacts in our solar system to keep an eye on us or just hang out. Heck, maybe they're building wild mega engineering projects, like gigantic solar panels around their stars. Or they could be getting all fancy and contaminating their stars with heavy metals just to announce their presence. So the search continues. We're not giving up just yet. And hey, maybe instead of just focusing on smart space beings, we should be on the lookout for any kind of life at all. Yeah, I know that a tiny microbe might not be as thrilling as chatting with friendly otherworldly creatures. But think about it. There could be lots of simple life forms out there. We're talking about simple organisms swimming in oceans, mossy creatures holding onto rocks, or the first signs of critters exploring their habitats. They might not be super brainy, but they leave their mark. Plus, they could be way more common and easier to find in our galaxy. Now take Earth, for example. There's a theory that our atmosphere used to have a lot of oxygen floating around. But oxygen is a bit wild and doesn't stick around for too long. It either escapes into space or bonds with other elements, changing into different things like carbon dioxide. Then, around 2 billion years ago, single-celled organisms decided to gobble up carbon dioxide and burp out oxygen, completely changing Earth's atmosphere. Life here transformed the very nature of our planet. And guess what? We can actually detect changes like that on other planets. Here's how. When we look at faraway planets called exoplanets, sometimes they cross in front of their parent stars. As the star's light passes through the planet's atmosphere, it gets all mixed up with different elements and molecules in the air. And you know what happens? The light changes its flavor and color in a special way. So imagine you had a glass of lemonade and you added some fruit juice to it. The lemonade would taste different, right? Well, it's kind of like that with exoplanet atmospheres. When we see the star's light that has traveled through the planet's atmosphere, it gives us clues about what's in the air and how it's different from just the star's light alone. So by studying these changes in light, we can figure out what kinds of elements and molecules are present in the atmosphere of a faraway planet. It's like a cosmic chemistry experiment, and it helps us learn more about whether there might be life out there. So right now, we can only study the atmospheres of big planets that orbit really close to their stars. But don't worry, NASA's Transiting Exoplanet Survey satellite is on the case. It's finding lots of interesting planets that we can check out more closely with the super-powered James Webb Space Telescope. This amazing telescope can even sniff out if there's too much carbon dioxide on other worlds. And okay, let's be real, our first contact probably won't be as flashy as in the movies. No exchanging secret codes or figuring out ET customs. We won't be chatting about funky bodies or habits either. Instead, the first hint of life out there will most likely come as a little wiggly line on a graph. It shows us that living creatures have really shaken things up on their home planet. Even simple life forms can have a big impact on their environment and leave behind a noticeable trace. Sure, it might not be as wild as battling space robots or epic adventures, but imagine this. Finding any kind of life beyond Earth would be huge. We'd be calling home, sending messages like, "Guess what? We're not alone in the universe." It would be an historic moment we're celebrating. And by the way, we've already begun to find organic molecules in space. It's not a full-fledged life as we imagine it, but it's still pretty neat. For example, we've already started to find organic compounds on Mars. And there's a teeny-tiny chance that Mars once flourished with plants, and maybe even animals. This is just a possibility, but if it turns out to be true, it would show that the presence of living organisms in the universe is not as rare as it seems. The search for life in the universe is like a great detective game. We thought that finding it would be easier because they could do cool stuff like blasting radio signals or transforming their whole solar system. But looks like, in reality, things are much more complicated. Nevertheless, we shouldn't give up. Let's keep searching and hoping that this new study about radio signals brings some results. The planet races through space. Its orbit is unstable, like a pool ball gliding across the table looking for a target to collide into. Only this ball is the size of Mars, and it's going 9,000 miles per hour. Boom! It crashes into another planet. This Mars-sized object was called Theia, and what it smashed into was Earth. The impact released 100 million times more energy than the asteroid that wiped out the dinosaurs. The planetary collision threw tons of solid material from both objects out into space. But only one of the bodies survived. Theia was obliterated and then swallowed entirely by early Earth. But that debris didn't go flying endlessly into the cosmic void. No, something crucial happened. All those solid chunks gathered into a cloud. Gravity squished it together, pressing more and more. And in the end, our moon was born. So goes the theory. At the time of the impact, the solar system was just forming, and this rendezvous of epic proportions probably wouldn't have happened if it weren't for a newly formed Jupiter throwing Theia off its orbit and straight into Earth. Our young planet withstood the blow. Time passed, Earth evolved. Its surface will become unrecognizable over the next 4.5 billion years. It's hard for the human mind to understand this vast amount of time, so we'll squeeze it all into one day. If midnight is when Earth first formed from gas and dust that remained after the Sun's creation, the next 4 hours show a lifeless planet. Red hot, covered in lava, constantly bombarded by asteroids and, as you know by now, even a whole other planet. Yet life finds a way. The first cells appear. It's 4 a.m. on the clock. At 2:08 p.m., we see the first single-celled organisms form. It's not until 8:28 p.m. that sea plants appear. 20 minutes later, what's this? Jellyfish. After them, the planet flourishes with different fish, reptiles, insects. The forests grow at 10:30 p.m. Between 1056 and 1140, dinosaurs roamed the Earth. The giant lizards ruled our planet for less than 1 hour. A minute before the dinosaurs' extinction at 11:39 p.m., the first mammals began to run around the planet. At 11:58 and 43 seconds, humans appear. In the cosmic scale of things, we've only ruled this planet for 1 minute and 17 seconds. So here's the main question baffling scientists. Why didn't life on Earth ever stop? It had every chance to cease. Why didn't our planet become like Venus or Mars? They both once had an atmosphere and oceans. Today, they're lifeless deserts. Forget about complex scientific concepts and theories of the universe's structure. Our little rock and all its inhabitants are just incredibly lucky. Professor Toby Tyrrell at the University of Southampton used computer programs and climate simulations to solve the puzzle of why asteroid collisions and ice ages didn't turn our little rock into a lifeless wasteland. The research team took not 10, 100, or 1,000 virtual planets similar to Earth. They used 100,000 for the experiment. And every single one of those 100,000 were simulated 100 times. They exposed these virtual planets to different phenomena. They were bombarded by asteroids, frozen, exposed to epic eruptions of supervolcanoes that blacken the skies and block the surface from the sun's rays. Just 9%, or 8,700 of them, were successful one time in 100 simulations. Of that group, 4,500 planets remain inhabited 10 times. Only on one planet out of 100,000, life didn't stop all 100 times. If life is a lottery, Earth got extremely lucky. In 2009, the unique Kepler telescope was launched into space. Its task? Search one patch of the night sky, or 150,000 stars, for rocky Earth-like planets. Over 9 years in service, it ended up surveying more than 500,000 stars. In all that time, with all those observations over nearly a decade, Kepler discovered 2,600 possible Earth-like planets. The weird thing is, most of them are a type you can't find in our own solar system. They're something between the size of Earth and Neptune. But back to the real Earth. If you go far from the city and look up at the sky, you'll see an ocean of stars. If you're lucky and it's a clear night, with an unaided eye, you could count a maximum of 2,500 points of light. Yet, there are at least 100 billion stars in the Milky Way. Some estimates put the numbers of stars in the Milky Way up to 400 billion. So, where's this giant range coming from? Well, counting stars isn't exactly an easy job. Scientists obviously don't number each one individually, 1, 2, 3, and so on. You know how long it takes to count just 1 billion? Over 100 years. Now, multiply that by 400. Instead, they look at small patches of space and use some complex scientific formulas to make educated guesses of how many stars there are in total. You can do a similar experiment yourself. Imagine a bucket filled with 10 pounds of rock, sand, soil, and other items. Your job? Understand how many rocks are in that mix. We'll count only those rocks that are visible to us from above. Get a rough estimate of their volume and weight, what percentage of the total we can see, and with some calculation, you can get a number. Is it exact? Nah. Why? Because you can't know if the rocks in the bucket are spread evenly throughout, or if they're all about the same size throughout. What if the ones at the bottom, if there are any, are bigger or smaller than your sample view? They could have completely different weights and volumes. That bucket is our Milky Way galaxy, and the rocks you are counting are stars. The point? Scientists can't know for sure how many stars there really are. Maybe 100 billion, or perhaps 4 times that. Of those, 4 billion are like our Sun. With our own galaxy, the most accepted estimate for planets that could potentially support life is 300 million. Though, as the tradition of scientific inexactness goes, that number could be up to 5 billion or more. Either way, lots of real estate to choose from. And that's just the Milky Way. But get this, it's just one of 200 billion galaxies in the observable universe. The most recent research puts that number 10 times higher, something like trillions of galaxies in space. And we've only studied less than 10% of them. As for how many stars there are in the universe, scientists put it at 1 septillion. That's 1 followed by 24 zeros. Again, it's all estimates because we can't know for sure. So far, one thing is clear. Our Earth is the only place in the universe that we know of where there's life. And this planet has done everything it can to change that. Over the past 540 million years, more than 20 major extinction events have occurred. The last one was 66 million years ago. Yep, it was the one that took out the dinosaurs, and 75% of all life on this planet for that matter. An object 7 miles across in diameter smashed into our planet. It was going 120 times faster than the fastest car today. Over 900,000 miles all around the impact site, everything caught fire. A huge tsunami swept across the world's oceans. Billions of tons of dust and sulfur rose into the sky and blocked the sun's warm rays. A global cooling came to Earth. A little over 200 million years ago, there was a lesser-known extinction event that wiped out half of all life on the planet. Most likely volcanoes or an asteroid strike are to blame. Other theories say the movement of tectonic plates triggered another ice age. At that time, huge crocodiles ruled the Earth. They disappeared and new animals entered the arena of history, dinosaurs. But the worst this planet has ever seen was the Permian-Triassic event about 250 million years ago. 80% of marine life, 70% of land animals and plants, all gone. Volcanoes spewed out a colossal amount of lava where modern-day Siberia is, but it affected the entire planet. Around 445 million years ago, the dominant life form on our planet was marine invertebrates. There was only one continent, Gondwana, and plants were just starting to flourish on land. But something happened that took out 75 to 85% of all living organisms. It could have been an ice age, rising temperatures, or a more daring theory. Some think it could have been a huge star exploding 6,000 light-years from Earth. It launched a jet-like gamma-ray burst that ripped across space, and poor little Earth happened to be in its path. It burned off the ozone layer instantly. Yeah, we kinda need that thing to protect us. Case in point, no matter how much this planet, or even the universe, tries to wipe out life on Earth, which is here in the first place from unbelievable odds, life always finds a way.
Wow, the James Webb Telescope has been fully deployed. If you're interested in astronomy or space, you've got to be excited about the James Webb Space Telescope. Here's why. For starters, it's huge. How huge? The primary mirror of the JWST is over 21 feet wide. The Hubble Space Telescope, the previous largest eye in space, has a mirror of about 7 feet 10.5 inches. By comparison, if you place the two telescopes side by side, it'd be like putting a horse next to an elephant. And elephants are enormous. There's a perfect reason why the Webb, as it's affectionately called, is massive. It has to be huge because it's not an optical telescope in the traditional sense that most telescopes are. The JWST is an infrared telescope. It sees heat. Infrared light has a longer wavelength than visible light, so it needs a larger mirror to focus that light. So what do we have here with the James Webb Space Telescope? We have two never-before things going on. We have incredible technology and incredible science missions. Both the missions and the technology are out of this world cutting edge. The Webb is a classic example of engineering in the service of science. Because of its greater light-gathering power, the James Webb Space Telescope will be able to take images of things that we were never able to see before, but have always wanted to see. Things like exoplanets and the first galaxies in the universe. and stars and planets forming inside nebulae, and you can bet that there'll be plenty of surprises too. The James Webb Space Telescope has several technological tricks up its sleeve, which promise to provide its greatest scientific discoveries. The Webb has a coronagraph, and a very special coronagraph at that. The coronagraph is the tool that will allow the first real pictures of exoplanets. The coronagraph blocks out the bright pinpoint light of stars, which we already know have planets orbiting around them. Without the coronagraph, the starlight would make things too bright to see these planets, because planets are hundreds of thousands of times dimmer than the star. But with the coronagraph blocking the starlight, the exoplanets come into view. And the JWST coronagraph can block the light from up to 100 stars at once. We can expect a swarm of exoplanets. This brings us to the next high-tech gadget the JWST has up its sleeve, a no-slit spectrograph. Usually, an ordinary spectrograph will have a slit to allow a sliver of light to enter and be diffracted. Diffraction is the scattering of light to reveal the spectrum of the light's component wavelengths. But the James Webb Space Telescope's work is so sensitive that a sliver of light would overwhelm the optics. So a no-slit spectrograph was installed. The starlight gathered from the big mirror is sent into a fiber optic cable to send only a single spot of light into the spectroscope. And that's where the grism takes over. Sir Isaac Newton used a prism to discover the spectrum of sunlight, Roy G. Biv, as you may recall. But the Webb uses a grism. That's a compound word, like smog, which is smoke and fog. A grism is a graded prism. That means it has itsy-bitsy, teeny-tiny grooves that diffract the spot of light the big mirror sends down the fiber optic cable and into the spectrograph. The science of reading a spectrum of light is called spectroscopy. By analyzing the spectra of light from the exoplanets, the JWST will determine what gases are in the planet's atmospheres, as well as their density and even their temperature. It's an incredible advance in our knowledge. We'll be able to tell if a planet has oxygen or nitrogen, or methane, and other gases that may or may not indicate that the planet is habitable. Another Earth, perhaps. Presently, the JWST is parked in its permanent location. Unlike the Hubble Space Telescope, which orbits the Earth, the James Webb Space Telescope orbits the Sun. It orbits the Sun at one of the gravitational balance points between the Earth-Sun system. It just stays there without having to use much or any fuel to hold its position. So, as the Earth orbits the Sun, the James Webb remains parked at a spot that is also orbiting the Sun. There are 5 gravitational balance points between the Earth and Sun. They are called Lagrange points, after their discoverer, Joseph Louis Lagrange, in the 18th century. The Webb is parked at L2, the second of the 5 Lagrange points, which lies 932,000 miles out into space, way beyond the Moon. All this to observe a spot of infrared light. But first, the engineers must get, or acquire, that spot of light. To get a spot of infrared light, the 18 hexagonal mirrors had to be unfolded from their position inside the Ariane rocket that sent the Webb into space. Once the mirrors have unfolded, their positions must be adjusted to microscopic level accuracy so that all 18 mirrors produce a single image. Several tiny motors are attached to each mirror segment to make these adjustments. These motors, which must be activated individually, will gradually pull the honeycomb-like mirror segments into alignment. It's a critical part of the mission and takes months to complete. To align the mirrors to produce a single spot of light, the James Webb Space Telescope can't be jiggling around. The telescope must be kept absolutely motionless, and that requires 2 other cutting-edge technologies, the sun shield and the cryocooler. In space, direct sunlight is very hot, and shadow is very cold. Therefore, the James Webb Space Telescope brought along its own high-tech sun shield. It's huge, too, as big as a tennis court huge, comprised of 5 individual layers of Kapton film, only a millimeter thick. Each layer of the sun shield has to be remotely deployed individually using a system of 8 motors and 139 actuators with thousands of parts. The purpose of the sun shield is to help the JWST stay cold. The colder the better. And colder is what the cryocooler is for. Temperature can be measured 3 different ways: in degrees Fahrenheit, where water freezes at 32 degrees and boils at 212; in degrees Celsius, where water freezes at 0 degrees and boils at 100 degrees. But neither of these thermometers have a starting point. So, Lord Kelvin, in the 19th century, devised a third temperature scale, the Kelvin scale, which starts at absolute 0, the coldest temperature possible. The onboard cryocooler will cool the JWST to just 7 degrees Kelvin, 7 degrees above absolute 0. At this temperature, virtually all heat from motors is removed, and the telescope will be able to focus the light to a point without any noise, basically any motion interfering with the quality of the image. Finally, after all this incredible technology functions remotely as planned, we are almost ready to observe the infrared images from the giant multi-segmented mirror of the James Webb Space Telescope. Almost ready. A telescope can collect all the light it wants, but in the end, it must also be able to detect what it's collected. If the light is not detected, it's not truly observed. Enter the pièce de résistance, the infrared detectors. The Webb has 15 of them. The specially fabricated semiconductor material produces a slight electrical charge when struck by a photon of infrared light. The Webb's infrared detectors can produce a 1,000,000-pixel high-def image. A few of the detectors can produce a 4,000,000-pixel image. They must be durable enough to last 10 to 20 years without warping or corrupting, all while working at 7 degrees above absolute 0. In themselves, the infrared detectors on the JWST are an engineering marvel. But what are they going to take pictures of? The missions of the JWST. Well, they're cutting edge too. 70 of the first 280 target observations are exoplanets. Is there another Earth? Which exoplanets seem habitable? The Webb telescope will provide detailed spectroscopic analysis of the atmospheres of thousands of known exoplanets. For the first time, we will see images of exoplanets as they appear in infrared light. Cosmology, the study of the universe, is perhaps the primary mission for the Webb. Galaxies receding away so fast that their light is stretched into the infrared will be a prime target for observation. Hundreds of hours of observations are necessary to collect the faint infrared light from these first galaxies formed after the Big Bang. The JWST will give us a picture of what the infant universe looked like. Astronomers will learn new information about the dark energy that is driving the expansion of the universe and what role, if any, black holes play in the formation of galaxies. Star formation in the Milky Way and nearby galaxies is also part of the mission of the James Webb. By imaging hundreds of solar systems forming around newborn stars, astronomers will establish a definite history of solar system development. Now fact will replace theory, and a big step forward will be taken in our understanding of space. The James Webb Space Telescope is a bold endeavor that will mark an epoch time in scientific history. There's only one star in our solar system, the Sun. And all the planets orbit this star. But there are also systems where a planet orbits two suns. For example, Kepler 16b. It's an inhospitable and cold place, made of half rock, half gas. But the coolest thing there is that if you visited this planet, you'd see two sunsets and have two shadows. But astronomers seem to have found something rarer and more bizarre. There might be a planet that orbits 3 stars at once. The GW Uranus star system is around 1,300 light-years away from our planet. It's composed of 3 orange rings. They're made of dust and nested inside one another. In the center of this system, you can see 3 stars. 2 of these stars are binary. It means they orbit each other. The third star revolves around them. Scientists have found out that the 3 rings are misaligned. The innermost ring swings widely in its orbit, and the outermost ring has a tilt of 38 degrees. So, astronomers came up with 2 theories. The first theory says the break in these rings occurred because 3 suns created torque at the center of the entire system. Torque is a gravitational force that always acts toward the center. But sometime later, this theory was written off. There wasn't enough turbulence in these rings for this theory to work. The second theory claimed that this phenomenon could be happening because a planet formed inside one of these rings. A young planet could affect the gravitational balance of the 3-ring system and be the reason they were spread so far apart. There's a specific gap in the dust cloud. Based on its size, the planet we're talking about must be a large gas giant the size of our Jupiter. All space objects have been formed thanks to gravity pulling matter together. If there's even the slightest rotation at the beginning, the spin rate increases with time, especially when an object starts collapsing. That's why all space objects rotate, including dust particles and even black holes. Black holes lose their mass because of a thing called Hawking radiation. Their event horizons are becoming smaller, but this process is very, very slow. A black hole's event horizon is a point of no return. It's like a boundary that surrounds a black hole, and nothing, including light and radiation, can escape once it crosses this boundary. The average black hole would need billions of times the age of our universe to disappear completely. Our home Milky Way galaxy might also contain a supermassive black hole, but we're in no danger. One of the closest large black holes, V4647 Sagittarii, is most likely 20,000 light-years away. It's safe to observe the effects black holes create from a distance. Problems start when you get too close because of their mind-boggling gravitational force. Galaxies can consume one another, which is one of the ways how they evolve over time. Our closest neighbor is called Andromeda, and it's currently munching on one of its satellite galaxies. In the past, Andromeda ate at least 2 others. Plenty of star clusters are scattered all over this galaxy. Andromeda must have stolen these stars from other galaxies. Scientists have finally managed to identify those stars. They have tracked them back to galaxy mergers that happened billions of years ago. 10 billion years ago, our home galaxy also went through a collision. That's why now its halo isn't like the ones other spiral galaxies have. Scientists first thought it was several small collisions, but then they realized that most of these space objects in the Milky Way came from a single source. It was another galaxy, Enceladus, that the Milky Way collided with. The Milky Way and Andromeda galaxy might collide, but it's unlikely to happen in the next 4.5 billion years. Neutrinos are electrically neutral particles that are so powerful that they can go through miles and miles of lead, and nothing will stop them. Some of them are passing through your body as you're watching this. Neutrinos get formed both in the nuclear reactions inside alive stars and in the supernova explosions when stars go out. These particles are nearly massless. They need less than 3 seconds to get to the surface of the sun, and then they can reach our planet in only 8 minutes. There's a planet, TOI 1231b, around 90 light-years away from Earth. It's similar to our Neptune. It's a gas giant, but the most interesting thing is that this planet is likely to be rich in atmosphere. The planet is over 3.5 times as large as Earth and a bit warmer than we're used to, 134 degrees Fahrenheit. It orbits a red dwarf star, way smaller than our sun. But this star is also much older. 1 year on the planet is only 24 Earth days long. Even though the planet is close to its parent star, it remains relatively cold. That's because its star is on the cooler side too. Astronomers think they've seen clouds in the atmosphere of this mysterious planet, and maybe they're even made of water. This star and planet system is moving away from Earth pretty fast. That's why scientists easily detected hydrogen atoms that were escaping from the planet's atmosphere. Yep, that means the planet may even have a tail. A hypothetical white hole is a bizarre space object that is the opposite of a black hole. It's intensely bright and was first mentioned by Einstein in his theory of gravity. Most often, scientists talk about white holes in the context of wormholes. There's a theory that a black hole is like some sort of entry point to a tunnel that takes you through space and time. In this case, a white hole might be an exit located somewhere else in the universe. On the other hand, white holes don't necessarily need to be exits from wormholes. They could also be a slow-motion replay of how original black holes were formed. So, the formation of a black hole starts with an old massive star. After it collapses under its own weight, it usually turns into a black hole. But sometimes, quantum processes don't turn a star into a black hole. Instead, they make a white hole that starts spewing out the matter of the original star again. But so far, this is just a theory. Some planets, like Mars and Venus, have pretty intense weather with powerful storms. And now, an equally strong space hurricane might have come to Earth. It was a swirling mass of air, about 620 miles wide. Satellites spotted the hurricane hundreds of miles above the North Pole, somewhere in the Earth's upper atmosphere. The hurricane was raining not water, but electrons. It lasted almost 8 hours before it finally broke down. It was spinning in a counterclockwise direction. It's possible there are oceans hidden under the surface of the moons surrounding Uranus. Scientists have also been investigating the oceans on Jupiter's moon Europa and Saturn's moon Enceladus. These oceans are hidden below the moon's icy crusts. Uranus has 27 moons. 5 of them are especially big. Those are Umbriel, Titania, Oberon, Miranda, and Ariel. Back in the 1980s, when people sent Voyager 2 to get us some images of these 5 moons, scientists found out that they had lots of craters and were made up of ice and rock. Pictures astronomers got then also showed signs of liquid water. It was erupting from the moon's depths and freezing on the surface. One of the most plausible explanations was the oceans under the surface. As a moon moves around a planet, the magnetic field of that planet tugs at it. That is how the moon stays in its orbit. This tug generates an electrical current that transforms into a magnetic field. Such a magnetic field is called induced, and subsurface oceans might be the reason why this induced field can be produced. Saturn is well known for its famous rings, but Neptune, Uranus, and Jupiter also have rings. At the same time, Saturn has something really special we've never seen on any other planet. It's this huge hexagon storm moving around the planet's north pole. Each of its sides is almost 7,500 miles long. That's an area so great, we could place almost 4 Earths inside. According to thermal images, this hexagonal cloud pattern goes down into Saturn's atmosphere for around 60 miles. The planet is hiding behind thick clouds, and sunlight can't get through them. That's why astronomers can't see what exactly is going on there. But there are theories. Saturn is a gas giant. When gas deep inside the planet gets heated, it strays further out. Huge amounts of energy are released along with that gas, which makes it rise, expand, and lose density. The same processes cause hurricanes and tornadoes on our planet. On Saturn, whirling gases come out of a high-pressure zone located within Saturn's outer layers, and these gases trigger a powerful storm of such an unusual shape.
They aren't supposed to exist. No one expected to find them. Scientists can't explain how they formed, and still, the James Webb Space Telescope has found them. These 6 galaxies, as massive as our home Milky Way, are full of mature red stars. They're so far away from us that they look like tiny reddish dots, even to this extremely powerful telescope. Astronomers have analyzed the light coming from these galaxies and estimated their age. They appeared 500 to 700 million years after the Big Bang. So far, nothing surprising. Galaxies that young aren't exactly rare. Scientists think that our first star clusters could have sprung up soon after the universe left the so-called Dark Ages. Those were the first 400 million years of its existence. At that time, only a thick fog of hydrogen atoms filled the cosmos. What is extremely bizarre about these galaxies is their tremendous size and the age of the stars inhabiting them. But this doesn't coincide with the existing ideas about what the universe looked like and how it evolved in its early years. Plus, it doesn't match with earlier observations made by the Hubble Space Telescope, Wabe's less powerful predecessor. So, according to scientists, what are early galaxies supposed to look like? The answer is simple: young and small. And indeed, previously, most early universe galaxies we found were just space babies, blue and small. They seem to have appeared out of the primordial cosmic soup just recently, and were still building their early stars and other structures. Most young stars are actually blue. As they age, they acquire a reddish glow after burning through their star fuel and cooling down. That's why astronomers were not ready to see old red stars in those ancient galaxies Webb Telescope was built to discover. Another thing they weren't ready to spot was galaxies more massive than 1 billion suns, and still, it happened. The most massive galaxies discovered recently seem to have masses just twice or 4 times lower than that of the Milky Way. And the most astounding thing here is that these galaxies were already that big when the universe was a mere 3% of its current age. But before astronomers start rewriting their theories, trying to explain how such huge galaxies formed so fast after the Big Bang, we need to make sure that what we're looking at isn't some other space phenomenon. Even so, most alternative theories need totally new concepts as well. One of them goes like this. Perhaps stars in the early universe emit light in some unusual, exotic way. And since astronomers didn't know about it, they didn't include this possibility in their models. Or our understanding of how stars form might be inapplicable to the early universe. If any of these theories turns out to be true, it'll overturn our understanding of star formation altogether. Now, how about we talk about the device that helped astronomers to discover those bizarre galaxies? The James Webb Space Telescope is an absolutely stunning piece of equipment, which is around 100 times more powerful than the Hubble Space Telescope. And the latter has observed places that are 13.4 billion light-years away. The James Webb Telescope is also on the pricey side, to put it mildly. Even though originally, the cost of the telescope was estimated to be just 1 to 3.5 billion. The whole development process cost around $10 billion. For comparison, it cost NASA $4.7 billion to build and launch the Hubble telescope. It was another $1.1 billion to fix it in orbit. Even though the James Webb Space Telescope itself is 3 stories high and the size of a tennis court, its mirrors are the lightest large telescope mirrors of all time. During the manufacturing process, they underwent a 92% reduction in weight. When you look at them, the telescope's mirrors seem to be gold, but in reality, they're made of beryllium. This is a steel gray, lightweight, and brittle metal. A gold coating is applied to each mirror, that's true, but they can't be produced entirely out of gold, since this precious metal tends to expand and contract, even with small temperature changes. So, the total amount of gold in the James Webb Space Telescope is less than 2 ounces. That's a golf ball-sized piece of gold. And the gold plates covering the mirror are only 1,000 atoms thick. As for the telescope's abilities, it would be able to clearly see a US penny from 24 miles away and a football from 340 miles away. James Webb's telescope side is cooling itself down, and its temperature doesn't rise higher than -370 degrees Fahrenheit. That's cool enough to make liquid nitrogen. A truly enormous 5-layered sun shield surrounds the telescope and reflects away as much sunlight as possible, letting the telescope stay cool. JWST is believed to be able to detect water on distant exoplanets. For a long time, astronomers have been discovering planets orbiting stars outside of the solar system by monitoring slight dips in stars' light. Such dips happen when planets pass in front of them. Plus, it's possible to read unique signatures in the light. This can tell us about a planet's chemical composition. And the strongest and most readable signatures happen within the infrared spectrum. And guess what? James Webb has state-of-the-art infrared instruments. They can help scientists spot new planets and even identify the presence of water there. The telescope was launched near the equator because Earth spins a bit faster there. And this gave the rocket some extra push. When the James Webb Space Telescope runs out of fuel, it'll keep orbiting the Sun indefinitely. On the other hand, even though the telescope wasn't actually designed to be serviced or upgraded, it might potentially be refueled with the help of robots. This would extend its lifespan. Interestingly, at first, Astronomers were sure that finding something exciting with the help of James Webb would take time. They thought that the first discovered galaxies would be so small and dim that the telescope would only find some remote candidates at best. But it didn't go as planned. As soon as the first images were released, scientists started finding countless galaxies, bright, large, and impressively old. The competition is still on. One research group after another spots new record-breaking worlds. One astronomer even said that the scientific world was freaking out since no one had actually expected such impressive results. One of the main goals of the Webb telescope is to observe the light from the very first stars and galaxies in the universe. Unfortunately, the farther away an object is, the faster it's moving away from us. And the longer the light has to travel, the more it stretches towards the infrared side of the spectrum. This is called redshifting in astronomy. But thanks to its infrared equipment, James Webb can reveal previously invisible worlds to us. So, thanks to this telescope, we've managed to see incredibly distant galaxies that were born around 3.8 billion years ago. It means that the light JWST detected took more than 13 billion years to reach Earth. Can you imagine that? But one of these galaxies stands out from the rest. It appears to be the oldest galaxy astronomers have discovered so far. It's called Glass Z13, and it dates back to a mere 300 million years after the Big Bang. The previous oldest galaxy scientists identified was found by the Hubble Space Telescope, and it dates back to 400 million years after the Big Bang. During that scarcely probed era, the very first galaxies and stars started to appear. But how exactly did this process unfold? No one knows for sure, yet. It might have depended on the laws of some exotic physics, including the influence of dark matter and dark energy, or some poorly investigated communication between gas, dust, and starlight. With the help of the Webb telescope, scientists can now test their theories about what was happening out there after the birth of the universe.
Oh, fasten your seatbelts. We're setting course for the most bizarre places in our universe, and you'll see the most mysterious phenomena few people have ever seen before. Recently, astronomers have discovered that the supermassive black hole at the center of our home Milky Way galaxy might be leaking. Why is it a significant change? Because it might mean that this black hole, called Sagittarius A star, whose mass is 4.1 million times the mass of our Sun, isn't a sleeping giant as previously thought. It might still be active. And the leakage, recorded by scientists, may be the hole hiccuping while swallowing clouds of gas. Hey, I've been known to do that from time to time. During the research, the team of astronomers used the Hubble Space Telescope. It helped them spot a jet that looked like a blowtorch. It was pushing into clouds of hydrogen at the center of our galaxy. The jet seemed to spew gas like a hose directed into a pile of sand. This often occurs around other active black holes surrounded by the material drawn to them by their immense gravitational pull. Some of this material gets pulled into the black hole, but a small part of it gets swept outward by powerful magnetic fields. The research suggests that when a giant gas cloud gets too close to our supermassive black hole, it gets swallowed, and then the hole belches small jets of matter. Fermi bubbles might be the result of the belches that occurred around 2 to 4 million years ago. But recently, scientists have found another giant glowing bubble of hot gas. It aligned with the jet stretching for 35 light-years or more from the supermassive black hole. Astronomers suspect that the jet could have plowed into this bubble of gas and inflated it. Now, let's visit some other breathtaking places in our universe. But be careful, some of them are extremely dangerous. Like this rotating neutron star called the Black Widow Pulsar. Just like its spider namesake, it's munching on its partner, a lightweight brown dwarf star. The more material this pulsar consumes, the more slowly it spins. The energy the neutron star is losing in the process causes the companion star to dwindle. If it does exist, nuclear pasta is the strongest material in the entire universe, formed from the leftovers of extinguished stars. this substance gets squeezed into spaghetti-like tangles of material. It can break, but only if you apply 10 billion times the pressure needed to shatter steel. How about visiting a planet where it rains glass? Nah, I'd rather not. You see, this bright blue exoplanet looks peaceful and slightly familiar. Don't you think it slightly resembles Earth? But this pretty appearance hides the planet's terrifying nature. The winds blow at 5,400 miles per hour on its surface. That's 7 times the speed of sound. But that's not the worst. It rains glass sideways in this scorching hot alien world. Solar tsunamis are a solar phenomenon dubbed Terminator events. These tsunamis take place at the sun's equator. Disastrous magnetic field collisions seem to cause ginormous twin tsunamis of plasma. These tsunamis tear across the star's surface, moving at a speed of 1,000 feet per second. They can last for weeks at a time and happen every decade or so. Now look at this space body. Its nickname is Electric Hyperion. This Saturn's moon is one of the most bizarre-looking moons in the solar system, but its appearance isn't the strangest thing about it. This pumice stone-like rock, pockmarked with countless craters, is also charged with static electricity, and it's flowing out into space. Look at this, a rogue planet with auroras. Lost in space and drifting through galaxies, rogue planets were once flung away from their parent stars. But one of them, 200 light-years away from Earth, is different from the rest. It's a planet-sized object with a magnetic field 200 times stronger than that of Jupiter. This field is so powerful that it generates flashing auroras in the planet's atmosphere. Be sure to stay away from black holes. Do I really need to warn you? Yep, they're some of the most perilous objects in the universe. But how about mini black holes? Unlike their massive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. Even so, just one minuscule thing would have the mass of 1,000 sedans. One theory claims that tons of micro black holes could have been created right after the Big Bang and the beginning of the universe. Some scientists even go as far as to say that a couple of mini black holes pass through our planet every day. Ooh, I'll bet you like our next stop, a burning ice planet. Faraway Neptune-sized exoplanet Gliese 436b is a paradox. It's made of scorching hot ice. The planet completes one full orbit around the red dwarf Gliese 436 in just 2 days. It means it's traveling remarkably close to its parent star. That might be the reason the planet's temperatures rarely drop below 800 degrees Fahrenheit. But the strangest thing? The planet hosts huge volumes of water ice known as Ice X, which remains solid despite blistering temperatures. Now, if you love jewelry, this next world is for you, a diamond planet. About 4,000 light-years away from Earth, there's a planet that seems to be one enormous diamond. The planet is denser than any other discovered so far and consists mostly of carbon. It's so dense that astronomers think this carbon might be crystalline. This in turn might mean that at least some part of the planet is diamond. Moons orbiting other moons might exist, or they might not. Astronomers haven't agreed on this one yet. Planets orbit stars, and moons orbit planets. But then, why can't there be moons, also known as submoons, moonettes, and moons? It actually sounds like one of those flowery Hawaiian dresses, moo-moos. But alas, no. Researchers claim that moons could exist, but the host moon has to be massive enough, the moon small enough, and there must be a wide gulf between these moons and the host planet. Now, I'll take you to the living fossil galaxy. DG-SAT-1 is as big as the Milky Way, but it's nearly invisible because its stars are spread out incredibly thinly. But what makes the galaxy unique is that it's sitting all alone, unlike other galaxies of this kind. Those are usually found in clusters. It can mean that DG-SAT-1 was formed in a different era, probably a mere 1 billion years after the Big Bang. If it's true, this galaxy is a real living fossil. Now, you won't be able to see the next space phenomenon, all because people can't see infrared light. And the phenomenon I'm talking about is an infrared stream from space. Ooh. Neutron stars are ultra-dense collapsed cores of giant stars. They usually emit X-rays or radio waves. But in 2018, astronomers discovered a weird stream of infrared light. It seemed to be coming from a neutron star 800 light-years away from our planet. This signal was probably generated by a disk of dust surrounding the star, but this theory hasn't been proven yet. Behind the orbit of Neptune lies the mysterious Kuiper belt, filled with massive icy objects. The most curious thing about this space formation, though, is that scientists fail to explain the pattern of its movement. The only explanation they have is that Neptune might be hiding from our sight a ginormous planet. This hypothetical planet has already got the name Planet 9, and all we have to do is wait until its existence is confirmed, or not. Let's visit our star, but we need to be careful not to come too close, because the Sun's atmosphere is hotter than the surface of the star. While on the surface, the temperature reaches 10,000 degrees Fahrenheit, the upper atmosphere heats up to millions of degrees. Scientists suspect that explosive bursts of heat from the Sun may have something to do with this unique phenomenon. Now, this space object is also worth visiting. Haumea, a dwarf planet orbiting in the Kuiper belt, has a bizarre elongated shape and 2 moons. The day on this planet lasts 4 hours, making it the fastest spinning big object in our solar system. But the most mysterious thing about Haumea is that the planet has a thin 40-mile-wide ring circling it. Ring-a-ding-ding.
The James Webb Space Telescope, an astounding piece of equipment built to outperform the Hubble Space Telescope, has made a terrifying and amazing discovery that might completely change our perception of the universe. It has successfully detected a faint glow coming from a staggering 7 trillion miles away. Can this glow be shining city lights coming from some mysterious extraterrestrial world galaxies away from us? Well, let's start from the beginning. A few years ago, NASA's infrared Spitzer Space Telescope helped us spot a family of 7 rocky exoplanets orbiting the same star. This star is known as Trappist-1, and recently, our new infrared powerhouse, the James Webb Telescope, has measured the temperature of one of those distant worlds. It was a planet called Trappist-1b. Unfortunately, it turned out that this Earth-like planet was totally uninhabitable. Astronomers took James Webb's mid-infrared camera, called MIRI, and looked at the planet's thermal emissions. We can picture the whole process as scientists using heat-sensing Terminator vision. The results were quite disappointing. Trappist-1b turned out to be scorching. Its average temperature was around 450 degrees F. That's as hot as in an oven. Plus, the planet most likely doesn't have any atmosphere. At the same time, this discovery was another record-breaking first for the telescope, which had already produced some newsworthy results by that time. It was the first time researchers detected any form of light emitted by a small and relatively cool exoplanet similar to the rocky planets in our own solar system. No previous telescope had enough sensitivity to measure such dim, mid-infrared light. When 7 Trappist-1 exoplanets were first discovered, the astronomical community was ecstatic. That's because all those faraway worlds were about the size of our home planet and located in their star's habitable zone. It's the region that is just the right distance away from a star for liquid water to exist on a planet's surface. Thus, the planetary system became the best place to look for rocky planets with an atmosphere. But don't get too excited yet. These planets aren't likely to become new worlds for humans to explore, mostly because the Trappist-1 planets are totally out of our reach at the moment. They're just too far away, at a whopping 235 trillion miles away. Their star is also much smaller and redder than our Sun. It's classified as an M-dwarf star. In our home Milky Way galaxy, there are twice as many of such stars as there are stars like the Sun, and they're also twice as likely to have rocky planets orbiting them. It's probably not surprising that astronomers are very interested in such stars. They're the main targets for seeking potentially habitable planets, and it's also way easier and more convenient to observe rocky planets around such smaller stars. But there's a catch. M-dwarfs are more active than our Sun. They frequently flare and spew high-energy rays which are likely to be extremely damaging to planets' atmospheres and any forms of extraterrestrial life. When researchers examined Trappist-1b before, their observations weren't sensitive enough to determine whether this world had an atmosphere, or if it was just a barren rock. But now, we know. The planet is tidally locked to its star, which means that one of its sides always faces the star, while the other is stuck in perpetual darkness. The latest simulations suggest that if this planet had an atmosphere, its temperatures would be much lower since the air would redistribute the heat around both sides of the planet. Unfortunately, The James Webb Telescope recorded much hotter temperatures than needed for such a favorable scenario. It indicates the absence of an atmosphere and knocks the planet off our list of possibly habitable worlds. But the main excitement here isn't actually the features of Trappist 1b. The main takeaway is that James Webb is capable of making such kinds of measurements. It'll help us explore the atmospheres and temperatures of many other distant worlds. Space, the final frontier. It's a vast and mysterious expanse that has fascinated us for centuries. But as much as we've learned about it, there are still plenty of things that we've been lied to about when it comes to space. Let's take a look at some of the biggest lies we've been told about this topic. First off, we have the idea that space is just this pristine, untouched wilderness. But that's not exactly true. We've been littering space with our debris for decades. Everything from old satellites to rocket parts. In fact, there are over 20,000 pieces of debris orbiting Earth right now, and they're causing all sorts of problems for future space missions. So if you're planning on visiting space anytime soon, watch where you go. You never know what kind of garbage might be floating around. Did you know that the sun is not actually yellow? It's green. Well, kind of. You see, scientists measure the temperature of a star by the color spectrum it emits. Cooler stars appear red, while the hottest of stars look blue. Our sun emits most of its energy at a wavelength that's close to green. But because it emits other wavelengths too, all these colors mix together, and your eyes see this vibrant mixture as white. From Earth, however, the sun looks yellow because our atmosphere is really good at scattering blue light. If our star was actually yellow, Earth would become a frozen rock, and we'd all be polar bears. Plus, the sun isn't on fire for real. It's a big ball of gas, mostly made of hydrogen and helium, and it works more like a gigantic nuclear reactor, constantly fusing hydrogen atoms to create helium inside its core. This process releases enormous amounts of energy. That's why the sun is so hot. Oh, and speaking of setting things on fire, explosions in space aren't real. Sorry, Star Wars fans, a spaceship can't go down in a violent blast because there is no air out there in space. No air means no oxygen, and no oxygen means no fire. Now, you might also think that there are too many stars in the night sky for you to count, but in fact, you can do that. According to the Yale Bright Star Catalog, there are 9,110 stars that you can see from Earth with the unaided eye. So, technically, you can count them, but I wouldn't be surprised if you lost count. And if you're worried about flying through an asteroid belt, don't be. Although it does have trillions of space rocks that range in size from space dust to a quarter of the size of the Moon, they're very spread out. The asteroid belt between Mars and Jupiter is 140 million miles across, which is 1.5 times the distance between Earth and the Sun. This spreads space rocks thousands of miles apart, making it almost impossible for a spacecraft to collide with one. You'll instantly freeze in space without a suit. Nope, you won't turn into a popsicle right away. It's going to take a bit longer than that because heat and cold don't really move very quickly in the vacuum of space. But unfortunately for you, there's a bigger problem at hand. You won't be able to breathe. After just 15 seconds, your brain won't be getting enough oxygen from your blood, and you'll pass out. And then after just 2 minutes, it's curtains for the rest of your organs. So, in short, if you find yourself playing astronaut without a spacesuit, it's game over pretty quickly. Did you know that space doesn't have any temperature at all? That's because the temperature is defined by the speed at which particles move and the amount of energy they have. In the true vacuum of space, there are no particles to move around, making it temperatureless. Of course, some parts of space are really hot, like areas around stars. But the further away you get from stars, the more spread out particles are, making those areas of space pretty chilly. Number 9 is our planet's shape. No, it's not flat, but it's not a perfect sphere either. Yeah, it bulges at the equator because of our planet's wild spin. It's like Earth is doing its own little dance. And because of this bulging, launching spaceships from the equator is much easier than from the poles. Now, when it comes to sound in space, it's a bit of a tricky situation. You might think that no one can hear you scream, but that's not entirely accurate. The thing is, sound needs something to travel through, like air or water. In space, things are super spread out, so all those epic space battles and galactic explosions would be completely silent. Yet there are some places in space with enough particles for sound to travel through. For example, you can hear the black hole at the center of the Perseus galaxy cluster. Another myth is about zero gravity. That's not a thing. There's still some gravity hanging around the International Space Station, about 90% of what we feel on good old Earth. But astronauts get to float around because they're basically free-falling around the planet. And let's be real, Hollywood's version of space travel is not factual. Sure, orbits are a thing, but different altitudes mean different speeds. So moving from one orbit to another isn't exactly a walk in the park. You can't just push yourself in the right direction and hope for the best. You gotta take those orbital velocities into account. This reminded me of the 2013 movie Gravity and how Sandra Bullock tried to survive in space. Hollywood sure added some fuel to these myths. Yet again, who can blame them? Back in 1976, NASA's Viking 1 spacecraft snapped a photo of a curious rock formation on Mars that looked suspiciously like a face. Some folks out there claimed that it must have been proof of extraterrestrial life on the red planet, but NASA had a different take. According to the space agency, the face was nothing more than a bunch of rocks piled up in such a way that the shadows they cast created an illusion of facial features. It turns out it was just a regular hill that got a little too much credit for being photogenic. The solar system stays in place. Lie! It's zooming through space at a speed of 140 miles per second, which means that it's whizzing through the cosmos faster than a cheetah chasing its prey. It takes us 230 million years for the solar system to complete a full orbit around the Milky Way. It's a good thing it isn't getting a speeding ticket, because that would be one astronomical fine. Eh? Without the sun, planets would be pretty chilly. We're talking about temperatures as low as -455 degrees Fahrenheit. Brrr. But with the sun around, the planets get to enjoy much more livable temperatures. Of course, not all planets are created equal. Mercury, for example, is the closest to the sun. Venus, on the other hand, is farther away, but somehow manages to be even hotter than Mercury. The distance from the sun isn't the only factor that affects a planet's temperature. Other things like the planet's size and reflectivity also come into play. So Mercury being the hottest planet in our solar system is a false proposition. No, just because it's the closest one to the sun doesn't mean it's the hottest. Even though we've been deceived in some ways, that doesn't make space any less amazing. It's still a vast, beautiful, and utterly fascinating part of our universe. And there's still so much we have yet to discover. Who knows? Maybe one day we'll really discover little green people out there. Or maybe we'll find out something even more incredible. Until then, we'll just have to keep dreaming and exploring. There, you got 14 things on our list. Do you have any other space myths to debunk?